Yeah. So hello everyone. This is Vishal, and so today we'll be solving some of the problems from the first week itself. Okay, we'll start then. Are you able to hear me? Like, can somebody?
Yes, sir. Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
Oh, okay, cool. So I'll try to uh, share the screen. One second. Okay, so are you able to see my screen, right?
Yes, sir.
Yes, sir.
Yeah, it's visible.
Okay. Yeah. So everybody can join the. I like everyone would be aware of this, right? Joinpd.com. Maybe you would have used this in the stats one, I guess, or maths one. So you can just type in your laptop joinpd.com, and then you'll be asked to type a code. You can type this code and you'll be able to join the solve with instructor session. So yeah. So just you have to type it. Yeah. So somebody had joined for the first. So we are 46. How many of we are? I guess 48. So okay. So I'll wait for 1-2 minutes. So everybody should join and then we'll start. What's the final date for the submission of your this first
assignment?
It's tomorrow, sir.
Okay.
Tomorrow.
Okay.
This week was hard. I mean, tough.
Okay. This week was hard.
Yeah, I don't know about upcoming weeks.
This was the most simplest I can say.
So actually, week 0 and week 1 content they released together. That was the problem for me at least, and I think for
What
many.
week? What
Week 0 and week 1 they
Yeah.
released it together, so we didn't get much time to focus on week 1.
Okay,
We had to
but
first
week zero is almost same.
yes,
Most of the parts are same as what you have learned in the stats.
yes, sir. But the thing is, last time I didn't take stat, right? It was before prior to that term, so I had forgotten a bit. So I
we
required
need to revise also, sir. What she's
Yes,
saying
sir.
that is absolutely correct. We need some time to revise also.
Yeah, I can get your point. Like I
So
understand.
stat was the most. I mean, for me at least, is the toughest thing, other than and compared to other subjects.
Like till now we have 2 live sessions, sir. So like almost in both the sessions we discuss more about week 0 only. Like Friday session was dedicated completely to distribution, and in the first lecture we discuss a mix of week 0 and some part of week 1. So ideally speaking, the concept of week 1 we could not discuss in live sessions. So there are several theoretical doubts itself.
Okay.
So I hope those will get addressed in today's discussion while solving the problem. So we can continue with solving the problem. So during solving the problems, those doubts can be clarified.
But tomorrow you have the the submission.
Yes. Tomorrow we have submission date.
Okay. If it was some days later, I would have taken some more session. But okay, it's fine. So you are having 2-3
Can't
sessions,
you
right?
take sessions tomorrow, sir?
Sir, we don't mind. You can extend date by 2 days.
No, like I can't extend. The thing is it's like been scheduled for all the courses, so like we can't do it for once. That maybe you are getting my point. So we can't, like I can't extend. If
No,
somebody,
sir. Can you take a session tomorrow, like before submission? Our submission date time is 11:59 at night.
tomorrow, okay, I'll ask them to take tomorrow. Like I can't take tomorrow. I have a flight tomorrow, so for the Chennai. but I can take day after tomorrow for sure. But the submission is on, I guess, tomorrow itself. But I can
Yeah.
ask, like, there are other people also, if they will be free, they can take the session. But we have like whatever the plan we have, I guess we have the session next. When is the next session?
Those sessions are
13th.
for sir week 2. I think.
Okay, that is for the week 2. Yeah.
Sir, I think for every week, if the open session comes first and then the activity or practice session, so that first the topics can be discussed and doubts can be cleared, and then activity.
Very valid suggestion. Very valid
Yes,
suggestion.
yes, very valid.
Yes, sir, it's good.
So,
Because
you
the
were having-
activity session came first, and like a few days later, then the open sessions are being planned. So, but there is a lot of gap.
So in open session, maybe you'd have discussed, right? Everything about that, everything
No.
about.
We had discussed about week
What she's
0.
trying to say, sir, like this Sunday, we discussed about distribution. So the open session came after activity session. So our request is that if we can have open session first and then activity session and then solve with the instructor. So that will create more impact.
Okay,
Yeah.
good. So okay, from the next week I can see why we are putting activities session in the first, like for the first like the first, what you can say, that session is we started discussing. We thought of we'll discuss the activity problems and mostly the practice, and then in the open session we'll try to discuss your doubts from the practice, or maybe some sort of points from the graded also, like where we will not solve all the whole problem, but we can try to just give you some impact of the questions if you are not able to grasp from the question itself. And then in the solve with instructor, we'll try to solve some problem before the submission date. Like if the submission date is tomorrow, we'll try to take 1 or 2 days before the solve with instructor, so that can help you in solving, because you'll be getting a bit same type of problem, some sort of problem from the solve with instructor itself. So you'll be able to solve.
Sir, every week solve with instructor is coming only on Tuesday. So every week it will be 1 day in advance.
Yeah. So every time the submission date is on Wednesday, right?
Right.
Yeah.
Okay. So you all are saying that open session should happen first and then activity, right?
Yeah. So because if we get any doubts from watching the videos,
Concepts.
so yeah, concepts, the doubts can be cleared first, so that we can try by ourselves to try to solve the activity problems by ourselves.
Okay. Okay. I'll just forward this message. Maybe they'll try to put open session first and then activity. But you all need one more session for week 1, right?
Yes, sir, please. Because I'm not able to, somehow I had solved the activity question, but I am not able to solve the graded question.
Okay, maybe
And
this
we
will
have not the feel of the course, sir.
what?
We have not the feel, understanding not clear too much.
Okay. So, okay, I'll try to sort out some, but mostly we'll be solving some problems only. If you face like any other issue, you can ask me on the mail ID tonight. If till
Can we have
tomorrow,
a session tomorrow afternoon, sir? Like what others are also
I'll
requesting
be
tomorrow.
free by after 4 only. So I'll just forward this message. If somebody is free, they can take this tomorrow. Some one session in the morning, maybe, because your submission will be by night, right?
Sir, and also one more
That will be
request.
great help, sir.
Actually, when I was taking statistics 1, we did not come across Poisson distribution. So can you help me where I can find the video?
A Poisson,
learn
I
about-
guess, is there in the week 0, I guess.
Yes, it's
yeah.
in week
Okay.
0.
Go through that. And Poisson is not that difficult. You should be aware of when to use that Poisson. And most of the questions, they'll be giving you have to use this Poisson distribution, and you already know the PMF, or how generally we write the Poisson distribution, or like formulas, and how to get the lambdas and all will be given. So you won't face much issue in the Poisson, that I can assure you. And binomial Bernoulli you must be knowing, and what else is there? So most of the
Geometric
time,
and negative binomial, these things.
Hypergeometric.
okay, so those hypergeometric and all will be using very less time, but yeah, that is important. You can, if you're facing issue, what we can do in the week 0, we what do you say? One session was there, no? Right? So we have not discussed
Yes.
the week
Sir,
0.
please, it's enough of week 0, sir. We are.
और निकिता मैम ने डिस्कस करवाया था पिछले सेशन में
Yes,
पूरा
that's what I told. Week 0 we are done more or less. Week 1, that's why we are following sort of week 1 concepts.
Okay. Okay. So yeah, so I'll try to take day after tomorrow only, because tomorrow I'll be totally packed. So I can't take tomorrow, but I can forward this. If somebody is free, they can take this session. Okay. But that
That
I
will be
can't.
a
I can't. I'm
good
not
help,
like.
sir.
Yeah, but that I'm not assuring. Like if I would have been free, I would have taken for sure. But I can take day after tomorrow. If you want, I can take the day after tomorrow session for week 1. But tomorrow I can't take. Yeah. And week 0, you can tell if whatever you have got the point, it's fine. If you're not getting, what you can do, whenever there is some session like open session, you can ask some chunk of problem. Like if somebody is having issue in that poison, you can ask there. Okay. And you try to like Google itself, like Poison, what is Poison and all, it will help you. Well, a little bit sort of things you can get it from the Google also. That will help
Yeah.
you.
Okay, sir.
Right.
Sir, if we have sufficient time after this solve with us, if you could summarize week 1's contents. Quite honestly, I'm completely clueless. I am not even able to do the activity questions, and I can't even venture to the grading assignment, and I'm on the verge of dropping this course in the first week itself. I'm thinking of dropping it. So if you could, after the solve with us, give us some guidance on week 1 contents, it would be really appreciated.
Okay, so I'll try to just what I can do. I can.
Yes, sir.
Okay, I'll try to what you can say in 5 to 10 minutes. I'll just say you the important things so that you can able to solve the problems of the graded. Okay.
Okay,
Thank
sir.
you.
Sir,
Till that
please
time.
let's continue because we are wasting a lot of time.
We have 40 students now, so I'll start it. So the problems are pretty simple. If somebody is not, see, what is good about the first week is if somebody is not able to grasp the joint or marginal or conditional, just go and have a approach, the basic approach that you have been able to solve in the stats one also, that the permutation combination you would have discussed binomial Bernoulli. So those concepts also you can use and will be in the position to solve the problem, that I can assure you, without knowing much about the joint and conditional also. Many of the problem, not all, but you'll be able to solve many of the problems. Okay. So yeah, so I'll start it, and if the time allows, I'll discuss the basic concepts of the first weeks, and I'll try and I'll give you the mail ID. If somebody is having any issue, you can mail me till night also, today or tomorrow also after 4. I'll be replying you for sure. Okay.
Thank you, sir.
Okay. So I'll start.
So you are giving the mail ID now or in the chat window?
Okay, I'll just write it outside. So this is just Vishal @online degree.
Can you spell it out, please?
I'll just type it in the chat box. Okay.
Yeah. How do I see the chat?
I guess this is the mail ID. Once I'll check it.
You have a very good mail ID. College has given.
So this you can mail me. Okay. So I'll be able to reply there. Okay. So you can ask me if you're not getting. I'll not solve if you are facing the problem graded also. I'll just try to simplify those issues so that you'll be able to solve. Okay. And if the problem is from graded and activity, I'll try to solve and send it send it to you. Okay, on the mail itself. Okay, I guess this will work, and so we'll start with the first question. So, okay.
Excuse me.
Yeah.
Yes, actually I joined right now. Where is the question?
Okay, I'll just go. Yeah, this is the first question. Maybe in this your screen also you'll be able to see that first question. So I'll spell it out. A fair coin is tossed 10 times. So everybody is able to see this, what you can say this.
Sir, could you
Yes,
please
sir.
say code? What's code?
Okay,
To
code
enter.
you have not joined. Okay, the code is this one, SND, small s, N for Nagaland, D for Delhi, F for Finland, I for India, and N for Nagaland again. So all are small, you can join it with this. Okay. Yeah, so the first question is, this is the first parts of the first question, and that is a fair coin. We are having a fair coin and we have tossed it 10 times. Okay, let x is a random variable, be the number of heads, and y be again a different random variable with the number of heads before the first tail. So see, if I'm tossing the coin for the 10 times, so the number of heads, whatever I'm getting, that is x. Okay, so that has been represented by x. And the number of heads I'm getting before the first tail. So if, for example, I'm getting the tail in the third trial, okay, so the y will be what? 2, right? So if I'm getting the tail in the third trial, so y will be equals to 2 because we have got 2 heads before that tail, the first tail, okay? So this is one example. If there is no tail in all the 10 outcomes, so if we have tossed and we have not got any tail, so at that point, y will be equals to 10. So now you have to calculate that probability of x equals to 4. X equals to 4 means what? You have got 4 heads out of 10, right? So I guess this is very simple and we'll be able to solve this. So I'll give you 2 to 3 minutes. You'll be able to solve. This is a pretty simple one. I don't think so. There is no concept of joint, conditional, anything. You just have to use some basic aptitude and you'll be able to solve. Okay, so I'll just open the joinpd.com. I'll write it in the chat box itself, joinpd.com.
So
open it and then just type the this code SNDFIN. SNDFIN. Okay, and you'll be here. Yeah. So somebody was asking something.
yeah, so basically the 6th can be a head again. 6th, 7th, 8th, 9th, 10th can be a head again.
So yeah, so it can be anything. We have been asked only for the X. You should not worry about the Y for this question at least.
Okay.
Okay, so you are just getting 4 heads out of 10. Wherever it is like coming, you should not worry about that one. Okay, we have just out of 10, I'm getting 4 heads. That's it. So this has been asked. So the probability of, if I'm tossing a coin, the probability of getting head or tail would be 1/2, right? So probability also, you know, the number of outcomes also you already know, and x equals to 10. 4 means you are getting 4 heads out of 10. So that also you already know. So out of 63, what?
How to enter the answer? How to enter answer?
You just have to write the answer and that's it. So there will be one option. So there won't be any option to submit. There will be only option to write the answer.
That's why
okay.
It is still blinking. That number is still blinking on my screen. So I'm not sure.
Okay, so I'll get the answer. So you should not worry about how to submit that. There is no submit button.
Okay.
Sir, total possible outcome could be 2 to the power 10.
A total possible outcome is we are tossing it 10 times, right?
Yes.
That is 10 only. 2 to the power 10, how you are taking? Okay, so 2 to the power 10, if you are solving with that method, that is also correct. If you are solving, if you are just using the basic permutation method, and out of that, if you are using, I'm assuming that if you have told 2 to the power 10, I'm assuming you are going with the permutation and combination method, where you are just out of 10 places, 4 places you are choosing, right? If you are
Yes,
solving
yes.
with that approach, so that is also correct. If you are just doing it in that way, 10 factorial upon 4 factorial into 6 factorial upon 2 to the power 10, that
You
is
can
also
go
correct.
through binomial route.
Yeah, but the best and simple method would be the binomial. It's pretty simple. Just the binomial distribution, you already know how to write the PMF of binomial. Okay, the basic formula, NCR into P to the power N Q N minus R. If you're knowing, you will be able to. Right. So I've got only 34 out of 68. So half of the people has answered. This is pretty a simple one. No.
Can you wait for a second?
Yeah, I'll wait for 1 more minute and then I'll.
Graded assignments are not so simple.
Okay. So then you can ask me, right? I'm giving you the mail. You can just mail me.
So I think this is actually one of the question in the graded assignment.
Okay, then it's fine, right?
This question?
Yes.
I don't
what they're
think so.
asking is different, but the question is similar.
So I have not seen that graded assignment, but okay, so can be a question, but most of the questions, whatever you're getting the solve in structure will be on the same pace of the graded, so that you will be able to solve the graded assignment. So everyone is done. Can I go and solve this? Can we go to the solution part?
Yes, sir. Please move
So
forward.
Madhumita, so you can just type it joinpd.com, and then you can just write the password is that SNDFIN. S for what you can say, sand, N for Nagan. I'll just type it there. So you can join with this, and I'll go with this. So I'll just see that response.
Yes, for Switzerland.
I tried that, but it's showing that there's some connection issue, it seems. So, is it to me only, or?
I guess many of the students have joined, so I guess this is the problem from your PC, or maybe you can refresh it and again join it. Right?
Okay, sure. I'll try again. Thanks.
Yeah. So this was pretty simple. So X generally is what? X was the number of heads I'm getting if I'm tossing the coin for the 10 times. So this is a simple binomial with the number of outcomes is 10, or the number of times we are tossing the coin is 10, and the probability of getting head or tail is half, right? So probability of getting X equals to probability of getting 4 head would be what? We are getting 4 head and 6 tail, right? So 10C4, and the probability of getting head is 1 upon 2 to the power 4 into 1 upon 2 to the power 6, right? So 0.20. So everyone, I guess, has got that 0.20.
Yeah. Yes, sir.
If anybody is having any issue in that, this questions, you can ask. Otherwise, we'll go to the second one. I don't think so. There will be any issue. Yeah. So should I go for the next one?
Yes, sir.
Yes, sir.
Yes, sir.
Yes.
Yeah.
Yeah. So yes, this is the next one. Yeah. So the next one is you are having the same problem, but here you have to find the conditioned one. Where the what is the condition here? Here the condition is y equals to 2. Y equals to 2 means what? You have got 2 head before the first tail, right? And the number of heads you are getting is 4, right? So what should you think here? So here the y equals to 2 means you have tossed the coin for the first time, you have got head. For the second time you have tossed, again you have got the head. For the third time you have tossed, you got the tail. That means y equals to 2. And with this condition, so like you have already know regarding the first 3 trials, right? The first 3 trials should be head, and tail. Now we have to worry about the rest 7, right? Out of that rest 7, how many of them are head? So 2 has already came. So 2 must be there. Like 2 more head should be there in the next 7 outcomes. Have you got the point? Like I've just
3, sir. 2 or 3.
What 2?
2 or 3, because we are getting first head.
Second also head we are getting. See, y is generally representing the number of hits before the first trial. So in the third trial only, we have got the tail. That's why we
got
are
it.
putting
Yes,
y
sir.
equals to
Yes, yes.
Okay. So I've just elaborated all the whole problems, and you'll be able to solve this question. If anybody has any issue, you can ask me right now. So only 18 have responded. So I'll just elaborate the question once again. So what has been asked here? You have been asked x given y equals to 2. That means what? Y equals to 2 means you have already got 2 hits and the third trial is tail. Okay. So, and you have to calculate x. So simply you have to calculate here x given y equals to 2. That means, and there the x, the number of hits, the total number of hits should be 4. And out of that total number of 4 hits, you have already got the 2 hits. And the third trial is tail. So you already know about the 3 trials. So you have been you are remaining with the 7 trials. And out of that 7 trials, you have to get 2 head and the rest would be tail, right? So you have to calculate the probability of the remaining 7 trials, where in that 7 trials, you have got 2 heads and 5 tail. You can solve this question with the different approach also, but the simple one I've told you now. Somebody can solve with the somebody can solve calculate the table all the values, and then he'll be, because here it has been asked regarding the conditional, he can find out the joint and then he can find out the marginal, and then he can calculate the conditional also. But that would be a very different or very, what you can say, a difficult approach to solve this. What I have told you is the most simple one. Okay, so 3 trials I already know. The remaining 7, out of that remaining 7, you have to get 2 heads and the remaining would be tail. That you have to calculate probability. Again, that would be a binomial one. So I guess you'd be able to solve this. 28 people have responded. I'll wait for 1 or 2 minutes, and yeah, we'll discuss this again. So everybody is answering a very most of you have answered a very different. How will you conclude that third trial? See, third trial is head. That's how we are able to say y equals to 2, right? So if the third trial is not tail, how can you say that the two trial was head? Okay, so y equals to 2 means what? We have got 2 heads before the first tail. right? So who was asking this? I guess you are clear with this now. So Syam Kumar Sinha. So are you able to like, yeah, okay, fine.
Yeah. Yes, sir.
Okay, so 42 people has responded, and all of you have given the different sort of answers.
Yes.
Okay, so I guess this is this 0.16, I guess, and many of you
Yes,
have
sir.
given 0.16 as the answer. How come different? Like, can somebody explain me how the answers you are getting is very much different from the exact one? Can somebody give me the approach?
It
How
will
we
be
have?
7C2,
Yeah.
right?
Yes, sir.
7C2.
Sir, can I speak, sir?
Yeah, you can speak.
Yes, sir. First, I'm doing what fxy x4 2. That means I'm total number of heads 4 and 2 heads before first tail.
Okay.
So I'm getting 21 by 1024.
Okay. How you have solved? You have okay. So x equals to 4. You have already know. So 4 heads
Yes,
are
sir.
coming, right?
Yes, sir. And the 2 heads are coming before the first tail. So what I
Okay.
did, I fixed 2 head in the first 2 position, and in third position I fixed 1 tail.
Okay, so you can just fix it 3. All the 3 you can
Yeah.
fix. You are remaining with
Yes.
7, right?
Yes, sir. And
Okay.
I have arranged the remaining.
Okay, so
remaining
you don't have to do anything with that 3. You don't have to do
Yeah.
anything with the first 3. Now you are left with
Yes, sir.
7. Okay.
Yes, sir.
So the 7
Yeah.
you can rearrange whatever you want to do. You can do with the 7 remaining only. You can't
Yes,
do
sir.
anything with the
Yes.
7 for the first 3 tries, right?
Yes, sir. Yes, sir. This was the approach, sir. And for y is equal to 2, what I did, I started from 3, 2 because 0, 2 is not valid. 1, 2 is not valid because if the number of heads are 0, then
Yeah,
how
I'm
can we
getting
get?
your point. Okay,
Yes,
so
sir.
you have got
So
okay. So out of the 7, you have just arranged the 2, means 7
sir.
factorial upon 2 factorial into 5 factorial, right?
Yeah. Yes, sir. Yes, sir.
Upon
Yes,
3
sir.
power 10, right? Okay, this is
Yeah.
a good approach. Yeah, this is correct. So
Yes, sir.
yeah, any other approach? Any other have somebody solved with the different approach?
Sir, if we go by 7C2 method, then will it be wrong?
What 7C2 upon?
Hello?
Yeah.
7C2, like binomial, like only
Yeah.
now I'm supposed to get
Hello.
two heads out of 7, right?
Yeah, correct.
So 7C2, 1 by 2 to the power 2, and then 1 by 2 to the power 5. So will it be wrong?
No. This is the
It will be 7C2 divided by 2 to the power 7.
simple. Yeah, this is the most simple one, and this is correct. Yeah.
Correct.
So
This
what is
correct,
the correct answer?
The correct answer is 0.16. So I'll go with the solution. Whatever he has said, I've solved with the same approach. So the first 3 trial you already know. The first 2 would be head, and the third is tail. So we don't have to do anything with the first 3, as we have been the condition of y equals to 2. So now we are left with 7 trials. Out of the 7 trials, you have to get 2 heads and 5 tails. So how can you get 2 heads out of 7 is 7C2 into 1 upon 2, that is the probability of getting head, into 1 upon 2 into 1 upon 2 times, and then 1 upon 2 to the power 5 because of the tail. Okay, so this is what you will get as 0.16 as well.
Sir, could you please?
We will not multiply.
Sir, could you please open the notepad and some sheets so to explain that scenario, sir? It's
Okay.
everything becoming very imaginary right now for us.
Okay, I'll just try to write some. Yeah.
So you can say this is like
the simple binomial.
So if y is given as y is given,
but we can say
given y
that
is 2.
it is joined by marginal. In that we can
solve with
do
the marginal also. Yeah, you can solve with the marginal. So you have to calculate the marginal and then divide it by fy of 2, right?
Yeah.
So that you have to calculate now. You have to again calculate the joint. you don't know about the joint distribution here, right? So you have to calculate the joint distribution for all the values, and then you have to sum and then divide it by the FY. So I'll try to write it, and then maybe it will clarify some points.
Sir, one query over here. X given y equal to 2, if it is given, that means whatever is, like, for example, y is given as 2. So we have to just exclude the values of x for that while calculating. I mean, I didn't realize that. So I got a wrong answer over here.
No, you have y equals to 2 means what? 2 heads has been occurred already, right?
Right.
4
Yeah.
heads out of the 7. So that you have to, you can't.
Okay, so that is already done. So we need not consider in the probability calculation.
Yeah, correct.
Okay, thanks.
Sir, one question here. So only if it is mentioned as joint PMF, then only we should use that formula?
Joint formula. Okay, can you repeat that? I didn't I've heard, but my mind was at different place.
If it is only if it is mentioned in the question that it is a joint PMF, then only do we have to use the formula?
No, you can use the formula here also, but the thing is, you'll be able to you'll be in a big trouble solving this.
Yeah, to calculate the marginal probability.
Yeah, you are correct.
Okay.
See, how generally you calculate the margin? See, here you have been asked what? You have been asked, this was the condition of x given y equals to what? 2, right? 4. So you can solve by this way also. You can just calculate the joint distribution and then 4,2 and then divide it with the marginal distribution of 2, right? This is the one approach. This is a pretty difficult in this scenario. That can be helpful in other scenario, but here it is difficult, right? Because you have to calculate the joint distribution for each and every point, right? And then you have to do the summation, whatever for the 4,2 you have to get from that table. And then you have to calculate this you can calculate simply. This is a pretty simple one. Y equals to f of y equals to 2 means what? You are getting head and tail, right? So this you can calculate directly. The probability would be a pretty simple. So this you can calculate, but for this you have to solve a bit lengthy thing, and then you'll be able to get the conditional. But here, how we have solved without using this method, without calculating the joint distribution of x and y, what we have done. So you have got y equals to 2. Y equals to 2 means what? In the first trial, you are getting head because you can't get tail, right? If you get tail here, so y equals to 0. That means y equals to 0, right? Because you have got the tail in the first, you have not got any head before the first trial, before the first tail, right? So, but here y equals to 2 means first would be head, second again would be head, third would be tail. Then only you have got the 2 heads before the first tail, right? And here x equals to what? You have to go. You have to get 4 head, right? So 3 is already, this is the conditioned one. So this we already know. Okay, so we have just we have just removed this. Now we are left with what? 7 trial. So 3 trial has been made. And this was the condition. That's why we are removing this one. So we are left with 7 trial now. So out of that 7 trial, we have to get 2 heads. So now we have to select 2 out of 7. And the probability of getting head is 1/2. And the probability of getting tail is 1/2. So that you can write it directly. This is a simple binomial. Binomial with what? Binomial with 7 trial and half of the probability, right? And 7 out of the 7, you have to choose 2. That you can solve with a different approach. 7C2, this also you can use, and then half, and what is this? 2, 1/2, 5, right? This also you can do, or you can do with a different approach also, like somebody was saying 7 factorial upon 5 factorial upon. This is the method that you have used in the permutation. How you are, if you have 7 different places and you have to choose the 2 or the 7 different, not choosing, you have to 7 different, what you can say, digits, and out of that 7 different digits, 2 digits are same and the 5 digits are same, and then you have to rearrange those. How can you rearrange? So to rearrange the 7 places, you write 7 factorial, and 2 of them is similar, so you'll write it 2 factorial. You'll divide it into 2, and if the 5 things are similar, then you'll divide it into 5 factorial, and the probability, the total probability will be what? 2/10, because for each of the places 2 things can come, right? So 2 to the power 10. So that is how, this is a one approach that if somebody is not able to know regarding the joint and anything conditioned and all, so he can go with this approach.
2 to the power 10 or 2 to the power 7, sir, here in this case?
What?
2 to the power 10 or 7 in this case, like divided, we are dividing by 2 to the power 10, right?
No, you have to take for all the cases, right? For all the 10. So you'll be dividing by 2 upon 10. Then yeah. So this is the one method. So I guess 2 to the power not 10. I guess 2 to the power 7 only. This is how this both will be similar, right? Yeah. So 2 to the power 7.
Yes, sir. 2 to the power 7. It will be.
Yeah, correct. You were correct. So this, I guess it is clear. If somebody is having any issue in this, you can ask in this problem.
So we are ignoring that conditional part, right?
Yeah. So why we are ignoring? Because why we are not ignoring. We have already taken this point. So the first 3 trials we already know, right? From the y equals to 2 point of view. If you have been given y equals to 5, so you already know regarding the for the 6th
Head
trial will
and
be tail and the starting 5 trial will be head, right?
head. Yes.
Yeah. So this is how we have been removing the first 3, and then out of the 7.
Yeah, here I was wrong. I had multiplied the both.
Okay. So it's not known. You can maybe sort out this, and then for the next time you won't do this. So we'll go through the next problem. Okay. I guess this is fine for everyone. So we'll go to the next one.
Can I ask a question here quite quickly? Is it, can you, without the binomial expression, is there a way of actually finding it out?
Okay, I've told you this method. This method is also a 7. If see how if you have been given A, B, B, right?
Correct.
Okay. This you can say this is head and this is tail, right? Or you
Yep.
can say this is head, tail.
Correct.
So this head can come here also, right?
Correct.
Anywhere it can come. So out of the 7, how generally you rearrange 7 factorial plus the method, and out of that 7, 2 is similar and 5 is similar. So 5 factorial upon 2 factorial.
Yeah.
Right. This is the probability of rearranging this one.
Yes.
And this you will divide it to 2 to the power 7. For each places we have tail or head, right?
Okay.
Right. So this was the probability. This is almost similar because here also what we are doing 7c2 and 1 upon 2 to the power 2 and 1 upon 2 to the power 5. So this is what 2 to the power 7. This we are getting, and 7c2 is this one, right? So this is what we are doing here also in the binomial. Okay, I've got the point. Maybe in the permutation you can correlate with the permutation combination that you have read in the stats one. So this is the one method. Yeah. So but this this will not help you in the next, like this will help you whenever there is a coin or dice and all. But this again you'll be in trouble if somebody has asked you regarding the boson and all. There you have to use some different approach. Okay. So in some cases this will help you a lot. The thing is, every time it will help you, but you have to think a lot. The general aptitude should be there. How you'll think and how will you generalize this problem in this way, permutation way. Okay. So here we are able to do this. Somebody was able to solve this with this method, but every time you won't be able to do this. Okay. So yeah.
Okay.
And the next, yeah. So see, sorry. This is the next one. So here, what is the so here in the explaining the earlier questions, I've already told you how to calculate this one, Fy of 2. That means what? You have got the third trial as tail and the first 2 as head. So you have to calculate that. So I'll give you 2 to 3 minutes. This is pretty simple one. You don't have to do anything in this.
Sir, would you please make understand this question?
What? Should I explain it? This is what you are. Okay.
Yeah.
So here, see, Fy of 2 is what? This is a simple marginal distribution, right? Of y. Okay. And for this marginal distribution, y equals to 2. That means what? The first 2 trial is head and the third trial is tail. This is what you have to calculate. The first trial should be head and the third trial should be tail. So HHT, how can you do that? HHT for head, you can get 1 upon 2. For tail, you can get, for head again, you can get 1 upon 2 and the tail 1 upon 2. So 1 upon 2 into 1/2 into 1/2. So the answer would be 1/8. What?
I'm not sure if my understanding is correct, but are we looking at only the first three terms? Because this can repeat over at least 3 times, right?
Yeah, so we are just seeing here for the first 3 tries.
Okay.
Yeah, because y equals to 2, right? If y was equals to 10, then you would have seen for all the trim.
Okay.
It means like the head came 2 times before the first tail, right? Why?
Yeah, this is what you have to calculate. The first tail, the third tail was tail, and the first 2 is head. How will you do that?
3 are fixed then, right? 3 are already fixed. Okay.
Yeah, so 1/2 into 1/2 into 1/2. So this, I guess, many of you would have solved, and most of you have got the correct answer. 0.125, I guess, is the correct one. If there is any issue, you can ask. I'll go with the. This was the. We have not started with the first questions. Okay, this was the all the 3 parts of the first question. So we have to be hurry now because we have already passed 50 minutes of our discussion.
Sir.
Yeah.
Sir, it has been told that the pair coin is tossed 10 times. And on the first 3 trials, we are getting 2 heads before the first tail.
Yeah.
And why we are not talking about the other 7? Because the coin has been tossed 10 times.
See,
and we are asking if
see, you will be considering those if you have to calculate other things also like joint and all. Here, what you have to calculate? You have been given like you have to calculate the marginal distribution for y, right?
Yes, sir. Then the marginal will go from the all the x for all the x summation of.
I'll tell you. If the marginal was to calculate f of y equals to 0, that will come at 0, right? F of y of 1 you have to calculate. That's in pass 1/2. F of y of 2 is what?
Sir, marginal of f of y is equal to 0. That means y.
No, 1/2. 1/2.
That means y is equal to 0. But we are not talking about x here. We will take all the x. Then we will do summation.
Yes,
right?
sir.
Yes, sir. What I am talking, we are not considering x here. That is we are tossing the coin 10 times and we are asking about the marginal.
Okay, see.
So we should also consider the x. I'm telling that. And
okay,
I am getting answer, sir, 0.123.
0.123.
Yes, sir. And what I have done, I have started from x is equal to 3 and gone till x is equal to 8. 3,2, 4,2. Yes, sir. 3,2 plus 4,2 plus 5,2 plus 6,2 plus 7,2 plus 8,2. That's it. Because we can't get, we can't take 9,2.
9,2 means you are getting 9 head.
9,2 means we are getting total 9.
You are getting 9 head, and then the
9 head. First 2 head on the.
Okay, so you are getting this head and tail, and then again all the head.
Yes, sir.
Right?
Yeah. So why you are not considering that, sir? Because we have learned that.
Yes, sir. Same question. Shouldn't it be over the whole range?
Okay, so what you are saying, so if y of 2 should be equals to, you have to take y equals to 2, and for all the summation of x should vary from 0 minus infinity to infinity. This is what
yes,
you're
sir.
saying. Right?
Yes, sir.
And see.
Yes, sir.
Okay. So f of y equals to 2, then what all are the value of x here?
X we will start from 3, sir, because 0, 2 and 1 is not valid here. 0 is 0 head and 2 head before the first cell. That is not possible.
See,
And one
so somebody
1,
has
is also not
replied very
possible.
correctly. So Nachiket had replied. So the summation, see, if you will consider that every time the summation value of x, you will consider all the value of x, right?
Yes, sir.
So for the marginal distribution, if you do the summation of marginal distribution of any one random variable, every time you will get the x, the summation as 1. So what if if you are considering some value like f of y equals to 0, okay? So if for all the rest is what? All the values of x you are considering, right? So if you are considering all the values of x and doing the summation, so what you can do, you can just take it in the bracket, right? For all the values of x. So the summation would be 1. Are you getting my point? Yeah.
If then for each we are getting 1. For f is equal to 2, 1, f is equal to 3, 1, f is equal to 4, 1.
So f equals to c. What is that?
Yeah. Are you telling that?
C. F equals to 2 is what? Head, and tail. And the rest
Yes,
we are not bothering about that, right?
So why? Because if you draw the joint PMF, how we were calculating the marginal? We are drawing the joint PMF.
If y of 2, so can I say something?
Yeah. You can say.
The if y of 2 is equal to means it can be implemented as p of y is equal to 2, means we are talking about only the event y. So in here that event y is that the number of threads for the first
Sir,
task,
can you draw the
as
joint PMF for some simple example and calculate some of the marginals? Then it will be clear, sir. Because
actually in this you can actually think that the rest of the remaining 7, like we don't have to consider. If we are only seeing about the event only, event y is there only, then in that way then we can say the rest 7 are not there. Or
Okay,
we don't have to consider.
how are we calculating the marginal? I just want to know that. How?
See, so
Yes,
this is
sir.
a simple, see, this was the question, and f of y equals to 2, right? So this simply means what? See, for the first question, if see, for the first question, that's what? First question, it was x equals to 4. And
Yes,
again,
sir.
if you have started bothering about the y, you will not get the correct one.
No,
What
sir,
I'm trying to say.
I have got the correct answer, sir. Previously, I replied. I calculated fxy 4,2 upon f
Okay,
of
so
2.
4,2 you have calculated. So 4,2.
I got 21 upon 1024 divided by
correct.
divided by 126 divided by.
So you have to calculate. Okay, so you're calculating fxy. So fxy can be directly written as the conditioned over y equals to 2 multiplied with f of y equals to 2, right?
Yes, sir.
Right? You can directly write it like this. Okay, and then what you have done?
I have calculated 4,2 as 21 upon 1024. 21 upon 1024.
Yeah, so somebody is written correctly. What is that? So if the first three tranches are, who is that? Can you speak out? Masoom. So first three. Yeah. I also feel like the same thing, because if you consider all the values of x, the summation should come at 1 only every time, right?
Sir, please listen, listen my solution, sir, first.
Okay, yeah.
fx y 4,2 I got 21 upon 1024. And f of 2 I got 126 upon 1024. F of 2.
F of 2 is.
Yes, sir.
F of 2 is
126.
Okay.
Upon 1024.
Okay, so see, if f of 2 is, if you have to calculate one. So f of 2 is what? You are getting this head, right? And this tail. This
Yes,
is what
sir.
you have been fixed. The remaining you are not aware of that. Correct?
Sir, I am aware. I am getting overall 3 heads. I am starting with 3,2. So I am getting 3 heads. So on the rest
I
of the
think
7,
so now you can consider 2 heads as well total because of remaining are all tails. So I think head count should be starting from 2.
See. If you have considered y equals to 2, right? So if you have to take all the, see, first thing that will not make any changes, how I'm saying you. See, and again, if you are considering all the values of x, so for the first value would be what? The number of head is only 2, and all the rest is tail. Have you considered this one? 2,8. 2,8 means what? 2,8 is 2 head and 8 tail. Means x is also 2 and y is also 2 here. And again, so I guess this you have not considered 2,2, right? You have started with 3,2. So if you'll consider 2,2 also, you'll get the same thing. Maybe I'm making you clear, right? So just consider that 2,2 also, and then do the summation, because we have to take all the values of x, and in the bracket will the summation will be 1. So I don't think so.
I'm missing this part 2,2. So, but sir, but this is the correct process to calculate the marginal, sir.
See.
That's what I am doing.
Yeah, you are saying it correct, very correct. So what I am trying to say, see, so this is the thing you should be worried. The remaining seven, you should not worry about that, because here it can be head, it can be tail, right?
Yes, sir.
Okay. So the getting head is what? 1/2. Getting tail is what? 1/2. So both will come in summation. If you do the summation of half and half, you'll get 1, right? And again for the next one, the fifth trial, you can get head also, you can get tail also. So this is a basic aptitude. If you are getting head,
but what about the choosing, sir? We are choosing that one that will get added.
No choosing. No. See, for the remaining 7, we are not doing anything.
The
We are not
only
doing anything.
choosing thing is here, na first, I guess. In
First
HSP,
3 only you have to choose.
the matter
Again,
is here.
the 7
Okay.
remaining 7, you don't have to do anything. Okay, it can come head also, it
Yes.
can come tail also. So the half every time it will get summation and it will get to 1. Okay, maybe I'm clarifying your doubts, right?
But this, sir.
Okay, you are worried about the 7. I'm aware of that. See, the simple, so maybe your calculation would be some error, but if I'm having only 4, I'm not tossing it 10 times, right? I'm tossing it 4 times. Okay, so here y equals to 2 means what? Head, tail, and it can come tail also, it can come head also, right?
Yes, sir.
Okay, so for this, if you do the summation for this, you will get some the probability is x for this, x into half, right? And for this again, x into half. This for head, this for tail. If you do the summation, we'll take the common half. So you'll get x, right?
Yes, sir.
Have you got the point? So maybe you are doing some error in the correction. Otherwise, you'll get x for sure. That's 100% sure, right?
Sir, I am missing that 2,2 part, sir. I haven't used that. I will use
Okay. So that is what I was saying. You'd have missed 2,2. That's why you are getting 0.123. So if you add, you'll get 0.125, right? Because you were missing 1. So that's why the probability was a bit less.
Okay, sir. Okay.
Yeah.
Okay, sir.
Yeah.
Sir, in this problem, like because the crossing points are independent, that's why it is working. But if in video in that
it will not work for
video
the
is there, like in IPL power play over,
no, it will
like
not
it
work.
is not independent, that is dependent, then it will not work, right?
No, it will not work. This is only for the independent one.
Independent, yeah.
Yeah. So the independent means what? Every time you are multiplying, you are getting the value. Okay. So for the one cases, if you have multiplied both the thing like conditional or margin, if you are not getting the joint, even for the one cases, so this is not independent. Have you got the point? Even if I'm having 1,000 matrix of 1,000, 1,000 cross 1,000, even for the one rows or one column, or even for the one element of that matrix, if I'm not getting the joint distribution as the product of conditional and what you can say marginal, this is not independent. Okay, have you got the point?
Sir,
yeah.
When we say two events are independent, right? Then their intersection probability should be equal to the product of their individual probability, right?
Yeah, correct.
Correct. That is the only condition, mathematical condition.
Yeah,
while we are tossing a coin, sir, then what is their intersection probability? Like PA into PV, that is getting 1/4. Say for example, I am tossing the coin 2 times, right? So what is the probability of getting 2 heads? So immediately I will multiply half into half. But what is in intersection? What is there in the intersection?
What is
like say for example, I am saying I am tossing a coin 2 times.
And the first is head and the second is tail.
Second is head also.
Okay, then also if you are getting this also, the probability would be what? 1/4 only. 1/2 into 1/2.
What is in the intersection? This H.
H, the first one is head and the second one is also head.
Okay, and if the second one is tail, then hello.
Okay, so you are asking what is the common between them?
Yes.
There is nothing common in them.
Intersection means common part, na? Like
yeah, so there is nothing common in them.
Then how come that 1/4 is coming?
Okay, so you are mixing two things. Okay, mutually exclusive and independent issue. Yeah.
No. In week 0 lecture also professor has said that whenever two events are independent, then there must be some intersection part. Intersection part means some common region, right? Professor has very clearly said that there should be some common part.
Yeah, sir. If there are two independent events,
I can quote the timestamp also.
No. Yeah, Joaz, whatever
sir.
you are saying is correct only. You're perfectly correct. So what is common thing between? So if you have what was this question? If you have tossed the coin for the 2 times, okay, right? So one,
so for example, the first time head and the second time tail.
If you are tossing the coin, for the 2 times, okay, this is the first trial. The value whatever you are getting the first trial, okay. This is the second, whatever you are getting head or tail. Both are independent of each other.
Correct.
Right? Okay, so whatever you are getting the first trial doesn't make any impact. Whatever if you are getting head, that will not make any impact in the second trial value.
Yes.
Right? Okay. And now next, what you want to say?
No, is it in the definition of independent events, we have learned that whenever two events are independent, then their intersection should be equal to product of their individual probabilities. Correct?
Yeah.
Like probability of A intersection B equal to probability of A into probability of B. This is the definition of, you can write it down. Yes, probability of A intersection B should be equal to probability of A into probability of B.
Right.
If this condition is getting satisfied, then only I can say that these two events are independent, right?
Correct.
So when I am tossing a coin 2 times, I know that tossing a coin is independent event, and I am asking the probability. What is the probability of getting head in first trial and tail in second trial?
What are the two events here, A and B? Like we are tossing the coin 2 times.
Probability of head and probability of tail in next event. That is the event. So it will be 1/2 into 1/2. That is 1/4, right?
Yeah.
So what is in their intersection? Left hand side is not clear to me. What is in their intersection? Because mathematically I have to prove this, na, that A intersection B also should be equal to 1/4.
Mathematically it is proved. Okay, so 1/2 and 1/2. So this is independent because the product is whatever you're getting is.
No, that is right hand side. Na, probability of A is 1/2. And probability of B is 1/2. So that is 1/4. Right.
Okay, and the probability of getting head, you're asking this one.
No.
Shall I interrupt?
Yeah.
Sir, shall I interrupt? Sir, इसमें what it happened actually, we are using that 5C4 nitro 10C4 that is making all the that it is coming here. How many times that it is intersection is there? In binomial theorem, they have given binomial probability. They have given HHT, THH, all these things they have given.
No, we are not talking about that problem now. That is done. This is related to a case independent event.
Okay, see, if you're asking how, if I'm tossing a coin, first trial I'm getting head, second
Right.
trial also I'm getting head. So here
No,
I can
tell,
directly
tell.
write one.
No, let us take tell, sir. Let us take tell.
Okay, tail.
Second trial tell. Yes, sir.
Tail. So 1/2, I'm getting 1/4. So what is the left hand side? Okay.
Left hand side is probability of A intersection B, right?
Okay, wait. Intersection. Don't mix up so many things here. If you have to calculate probability of head and tail.
It should not be like probability of getting head in first toss and probability of getting tail in second toss. Like intersection can be and, na?
Yeah, exactly. First is head and second is tail, right? So that is the AND condition, no?
No, intersection
that
means
is the
common
thing.
region. Intersection means common region. Whenever we have talked about intersection always means common region. Let us draw two Venn diagram A and B, and the overlapping part is called the intersection part, right?
But you are considering two coins, right? Like you are considering
There
head
also two
head
events.
tails.
There
So
also two events.
And means intersection.
And
I
that's
think.
what and means intersection. That's fine. But the left hand part is
yeah, so left hand part would be like when your first outcome is head, intersection of when the second outcome is tail.
So what is in common
So
part?
basically, it is I think is this way. The first is head and tail, second is head and tail. When it's intersection, the first head and the second tail comes together in that intersection. That's what I feel. Every coin is having two outcomes, right? Head and tail, right? So
I think he's trying to prove that P of head intersection tail, and that will be 0. But he's considering two coins. I think what's he trying to say?
I think it's he's trying to say that head into tail, head and tail. It means both are occurring. Head and tail both are occurring.
Trying to visualize the thing.
Boss,
I guess.
I am trying to say a very simple thing. The condition of independent event is that probability of A intersection B should be equal to probability of A into B. Is this the right condition, sir?
Yeah.
Yes.
So while I'm tossing the coin two times, yes, this is the right probability of A into probability of B,
If
right?
both are independent, then P of A into P of B.
Both are happening simultaneously, so we are multiplying them.
This
We are
is
tossing a
the
coin 2 times.
condition.
It can be also interpreted na, like tossing two coins simultaneously.
Okay. So whose doubt was this? We can
Mine,
discuss it later.
mine.
What's your name? I'll just mail me this one. I'll try.
Okay,
Maybe
sure.
we can connect later. Okay.
Sure. Okay. Thank you. Thank you.
Okay.
Sir.
What was your good name?
My good name is Ganga Prasad Tiwari.
Oh, okay. Thank you. I'll just mail me. Okay. Maybe we can connect it there. Somewhere else.
Sir, I want
again,
to say one thing.
Some Google Meet or somewhere. Yeah.
Sir, I got the answer, sir. 0.125. I solved it just now. Sir, I want to say that, but this was so lengthy process that I'm using, sir. So, sir, I want to say that if there is an independent distribution like this, and we are asked about the marginal probability, suppose f of 3, then we will consider for first 3 trials. F of 4, then we'll consider for first 4
trials only.
That's it, and we will not bother about the rest of that.
You should not bother about the one. The rest one. Okay.
Yes, sir.
Yeah.
If the distribution is independent.
If the distribution independent only, if the dependent is dependent, you have to consider everything. You can't find it in this way. Okay. So I'll go through the next one.
Sir.
Yeah.
Thank you, sir. Thank you.
What was the answer?
Let us move to next one, sir.
0.125. The answer is 0.125. 0.125. Because we were getting first head, then second head, and third tail. Okay. And the remaining, whatever you want to do, the summation would be
this
1.
This was not the question. I think we are on the next question. Yeah.
Oh, okay. So yeah. So for this one, this is what? This is a joint distribution with x equals to 4 and y equals to 2, right?
Yes. Sir.
So this is what? So how generally we split the joint distribution?
Sir, marginal into conditional.
Yeah. So joint, you can just remember, joint is what? Conditional into marginal.
We have already solved this.
Yeah. So the marginal you already have, y equals to 2.
Yes, sir.
Into the marginal.
1 point.
Right. So this was what? This was? This is point.
Conditional is 0.16.
0.25.
Yeah. So this we have to just
0.02.
Yes, sir.
This was it.
Somebody is Goswami. If two events are disjoint, that means occurrence of first event is ensuring that others not happen. Yeah, this is correct. And so yeah. Okay. So we'll go to the next one. Okay. So everybody, I guess, has answered it correctly. If anybody is having any issue in this one, you can ask, or else we can go to the next one.
Please move, sir.
Yes, sir. Please forward.
So this is the next. This is the first question. So we have already taken more than 1 hour for the first to arrive at the first question. The first one is you have to find it. The condition of y over x equals to 4. Okay. So x equals to 4 means what you are getting? 4 head out of 10. Right?
Sir, could you just give the previous answer, please? Show the previous answer.
Yeah, so this is the previous one, 0.02. 0.02, yeah.
This is the same as probability of x is equal to 4?
No, it's not same as probability of x equals to 4. X equals to 4 means what? You don't have anything conditioned and all. X equals to 4 means just...
It is. I think it is same as the next question.
See, I'll explain the first one. The probability won't be same for this 4,2 because here you have to consider x equals to 4 with y equals to 2, right? But in the first condition, the first problem, you just have to choose 4 out of 10. So that was a different thing. This is a different thing. Here you have to, with the conditioned one, you have to multiply the marginal also. The marginal we have calculated in the earlier problem. So marginal was 0.125, right? So the marginal what? 1 upon 2 to the power 3. And the condition, how you have calculated? 1 upon, what was that? 7. Out of that 4, we have, out of that 7, we have to choose 2 head, right? So 7C2 into 1 upon 2 to the power 2 into 1 upon 2 to the power 5 into 1 upon 2 into 3. 1 upon 2 to the power 3. So you have got 0.021. So what you are doing, so whatever you have got in the first problem, you are multiplying with the marginal one, right? So this is a different.
Sorry?
Yeah.
To the you're multiplying the conditional with the marginal of y.
Yeah. So how you have got the conditional? Because 3 we were moving because y was equals to 2. So we have removed the 3 trial and then we were working on the 7 remaining trial, right?
Okay.
Yeah.
9.
Okay. Is it clear? I'll go to the next one. This is the next question. So we have to find the condition of y. Distribution of y over x condition equals to 4 and their y equals to. So you can just use the formula. See, what is this? This conditional. So conditional is what? Joint upon marginal, right? So marginal of what? Marginal of x equals to 4, right? And the conditional that will work. Whatever we have calculated earlier, that will work here also because the joint will be what? xy of 4,2. So that we have already calculated, right? In the earlier problem, the joint for fx, the joint of fxy 4,2 we have already calculated. What you have to do here? You have to just calculate the marginal of y. I guess marginal of y also you have calculated.
Joint of
here we have to divide instead of multiplication.
Yeah, you have to divide it. See, f of y.
The joint of f of xy equals is same as f of yx.
Yeah. Those are same. Whatever you want to type. And f of x equals to a. This you have to do here. Yeah. This we have already calculated, right?
The bottom one also we have calculated. Denominator part also we have calculated. That was
bottom question. Also we have calculated, right?
Yes,
yeah.
That was first question.
That was the first one. So you just have to divide it. So yes. I guess this also. What is the answer? Can you spell out?
Point
1. Yeah, this is correct. 0.1 is the correct. So everybody has solved this one. Yes, how to do this? So if somebody is having issue in that conditional and all, so what you have to do? If you have to calculate the joint distribution, you have to just multiply the conditional and the marginal. Marginal, how generally you calculate the marginal? You have to take the 1 and you have to do the summation for all the remaining. I'll just, somebody was asking for some basic concepts. I'll just write it here so that from the next onwards question, you won't face any issue. So in this first week, we are what we have been just talked about. We have just talked about 3 things. The first one in the joint PMF. Right? And joint PMF is what? FXY of. Can you mute yourself? Whoever. Okay. So the joint is what? Probability of X equals to T1 and Y equals to T2. Right? You can't multiply this because this is a different scenario. You can multiply it if both things are independent of each other. Okay, this is the first. So there is only 3 things you are reading in the first week. First is joint PMF. The second is marginal. Okay, and how you will calculate the margin? If you have to calculate the marginal for fx, right? That is T1. So what you have to do, if you are having the joint distribution, joint PMF, so you'll just write the joint. Okay, fix the value of x here and do the summation for all the y. So the T2 would be variable. So T2 is variable. So this is variable. You have to fix this one. This is fixed. Okay. And if you have been asked to calculate the marginal for y, so what you can do? You have to just fix the value. Whatever you have been asked, just fix the value of y. Whatever you have asked. If you have been asked x, just fix the value of x. If you have been asked for the y, you can fix the value of y. And then you can do the summation for all the remaining things and we'll be able to.
Here we have been asked for x, no sir.
What?
Here we have been asked for x, right?
So you have to fix the x.
Yeah, variable will be y.
Okay, and the y is the variable.
Sir, can you please scroll up for a second?
Could you explain it further, sir?
Okay, so joint PMF, no issue in that.
No, joint is clear, sir. Joint is clear.
So for the marginal, if you have to calculate the margin, if you are having the joint distribution xy, what you can do? If you have to calculate the margin for x, you can just fix the value of x, okay, and do the summation for all the other y, whatever the value of the range, whatever the range of y, you just have to do the summation for all the ranges of the y. You have to fix the value of x. Like for example, if you are having table, in this table, this is a T1 and this T2. T1 is all the values of, like T1 is 0 and 1, and T2 is what? 0 and 1, right? So this is what? 0, 0. This is the joint distribution of 0, 0. Let the probability is A. Here the probability is B. Here the probability is C. Here the probability D. Okay. Now you have been asked to calculate the marginal distribution of x. X where x equals to 1. Okay. So you have been asked for the x equals to 1, right? So what you will do? You'll just fix it this. 0 is fixed. You have to do the summation for all the y. Means what? A plus B is the marginal distribution of x, where x equals to 0, right? If you have been asked to calculate the marginal distribution of x, where x equals to 1, what you can do? You just fixed it 1 here and do the summation for all the other value of y. Okay, so it would be b plus d. Again, if you have been asked to calculate the marginal distribution of y, where y equals to 0, you'll fix it this one and do the summation for all the x. A plus b is the value. Similarly, you can do it for the marginal distribution of y also. That is c plus d. Okay, is it fine?
What is the intuitive rationale behind it, sir?
What? What
is the intuitive rationale behind it?
Rationale behind it?
Right.
Okay, so you are asking what is the reason behind it?
Yes.
Okay, so if you have, see, simple, how generally you write this one? This you write it like this, right? And y can be anything. It's a variable. This is how you write marginal?
Yes.
This means what? You have to fix the value of x, the probability. Every time you are calculating the probability, you are fixing the value of x, T1. and y is different, like t2 dash.
No, let us take that example, sir. My x1 is t1 is having two range 0 and 1, and t2 is also having two range 0 and 1, right?
Okay. Mm-hmm.
So if I have to calculate the marginal probability of fx0.
Okay, so I'm just fixing x equals to 0.
Yes.
Y can be what? 0 and 1?
Correct.
So the probability of what? X equals to 0, comma y equals to 0, or probability of x equals to 0, comma y equals to 1, right?
Yes.
So x00 is what? This one?
Yes.
This is A.
Okay.
01 is what? 01 is what? A plus C.
Okay.
Okay, so what we are doing? We are fixing 0.
Okay.
And the variable is the value of y. So we are just doing the summation for all the values. Okay, got it?
Thank you. And sir, like joint probability, whatever in subscript we are writing, like f subscript xy t1 and t2, right? So t1 belongs to x and t2 belongs to y, right?
Yeah. So whatever you are writing in the pair, like if you are writing fxy,
sir, is there something called pairwise marginalization also? Because in lecture 1.5 or 6.
What?
Pairwise marginalization. Like
pairwise marginalization. I mean,
when professor started talking about more than two variables, right? When professor started talking about more than two variables.
Yeah, you can take whatever the number of variables you want to take. You can take 4, 5, 6 also. But the numbering should be correct. Like if you are taking
say for
f x y z.
Yes.
And according to x1, if that is t1 you are taking, whatever the t1 belongs to the what you can say, the range of t x.
Correct.
And y belongs to t2 belongs to ty. So you should write it like this one, t1, t2, t3. You can't jumble it.
Correct. Yeah. So while we started discussing about more than two variables, sir, so the expression of conditional probability became f x1, x2, x3. Could you write it down, please, sir? F x1, x2, x3 divided by
f x1, x2,
x3, x4.
x4 also. Okay.
4 also, and divided by f x1, x2.
fx1, x2.
Yeah, so professor called this term as pairwise marginal probability. So is it marginal probability of fx1, x2, or it is the joint probability of x1, x2?
I think it's the condition.
See, this is a joint one and this is the marginal one. So this is a conditioned over x1 and x2.
Correct.
x1 and
so
x2.
it's something over conditioned over x1 and x2.
Correct. So the formula of condition is always joined by marginal, right?
Yeah.
So whether fx1, x2 is marginal or joint, this bottom part.
This one is marginal.
Marginal.
You just have to fix the value of x1 and x2, some value. If this has been given fx2 as 0, 1. So you have to fix the value of x1 as 0 and x2 as 1 and do the summation of all the other values of x3 and x4, where all the values of x3 and x4 you have to take. Have you got the point?
Is it also called pairwise marginal?
The naming I'm not aware of that. But if somebody has seen the lecture, somebody can respond it. That is pairwise.
Yes, it is a pairwise.
So this is a pair. Generally, we say it as a pairwise. Okay, so we'll move to the next one. We are almost.
Sir, could you just show the last solution?
Okay, last solution. This one or the next one?
Yeah, this is the last one.
Okay.
No, this is not the last question we did, is it?
Okay, so this is the last one. But we have not discussed the. Yeah, okay, so this is the last one. And how we have solved this, I already have told you. You have to just divide the joint upon margin. Margin we have calculated in the first question itself. So the first one, whatever we have solved today, was the marginal of fx where x equals to 4. Okay, and the joint is what? 4,2. So joint of 4,2 also we have calculated. So what you have to do, you have to just divide it, and you'll get the value as 0.1. So is it fine? Shall I move to the next one?
Yes, sir. Yes.
Okay. So whoever has asked for the solution, should I move?
Just 1 second.
Oh, okay. I'll just wait for 10 seconds and then.
Yeah, sir, it's okay. Thank you.
Okay. So the next question, we'll move to the next one. Yeah, this is the next one. You have been given a table with a joint distribution. Okay, just to first calculate the value of A. This is pretty simple. I don't think so. It will take more than 10 seconds.
Yes, sir. Sir, move toward the solution, sir.
Okay. So I don't think so.
Just a second, sir.
Okay. Okay.
I have to input my solution.
Okay. Should I move?
Yes, sir.
Okay. So how come three people has written a different answer? They're pretty simple. This is simple properties. The summation of all
Sum
the
is equals to 1.
Yes, sir.
Yeah.
1, sir.
Okay.
That's
So now the next one. So now you have to calculate the conditional probability over like you have been conditioned over x equals to 0 with y equals to 2. Okay. So it's a simple formula. You have been given the joint distribution. You have to calculate the joint distribution of what? Can somebody tell me what would be the joint distribution? Which value, which element you have to take for the joint distribution?
0,2.
0,2.
Yeah.
Yes,
Yeah.
yes, sir.
A.
So every time, whatever the condition things is there, right? So here, what is the condition? X has been conditioned. Okay. So whenever you are using the formula, just you can remember in this way, whatever you're conditioning, that will come in the denominator. Okay. Every time, if somebody is getting confused with the formula.
Marginal will come in denominator. So
What?
marginal will come in denominator.
What marginal?
You said no, that's what will come in denominator. So marginal probability will come in whenever condition is asked. Right?
Yeah, the marginal one.
The marginal.
It's joint by marginal, right?
Yes, yes.
Yeah, joint by marginal. So the joint, no, I'm telling if somebody is getting confused, you want to divide. So whatever has been conditioned, like here it has been x has been conditioned, right? For
Yes.
equals to 0.
Yes.
So you have to calculate the marginal distribution of x equals to 0.
Sir, we got A as 0.2, right?
Yeah.
Okay,
Yes,
thank you.
yes.
0.2. Yeah, A is 0.2.
Thank you.
0.25.
सर वो लाइन फिर से रिपीट कीजिएगा जो बता रहे थे कि किससे डिवाइड करने वाला, वो आवाज आपको क्लियर नहीं आ रहा।
हाँ, so देखो
Joint by marginal.
डिवाइड किससे करना है? डिवाइड जब भी जैसे फॉर्मूला में क्या है, x इक्वल्स टू 0 है, कंडीशनड x पे है ना? जब भी x पे कंडीशनड होगा तो उसी से डिवाइड करेंगे. So whatever is there in the conditioned form, like x has been conditioned here, right? So you have to divide it with the marginal distribution of x, where x equals to 0. Fine.
Can we move to the answer part?
Yeah.
Yes, sir. Yeah. We.
So what's the answer for this question? 0.67. Everybody was correct, right?
Yes, sir.
Any issue? Everybody, anybody has any issue in this? You can ask. If not, we will move to the next one.
Yes, sir. Move.
Okay, we'll move to the next part. So this is the third question. So here, so 3 fair coin are tossed. If the first head occurs on the if the first head occurs on the first toss, he'll get 1 point. If the first head occurs on the second or third, he'll get 2 and 3 points respectively. If no head appears, you'll lose 1 point. So let X denote the number of heads and the Y denotes the number of points you have scored. So now we have to calculate the probability that more than one head will occur, and you have to score 2 or more. So for this, you just plot one table. Table means what? You have been 3 times you have thrown the coin. So you'll be having 8 column or 8 rows, horizontal rows. Yeah. So you'll be having 8 rows, and for all the 8 rows, just write the value of X and Y for all the values of X. Like if you have been all the 3 were head, so you'll get X as 3, right? And Y you'll get as 1. Because you are getting the first head, so you'll having 1 point. You'll get, if you have got the head in first go itself, so you'll have 1 point, right? You can just plot the table first. So for this, I'll wait for 5 minutes. Just plot the table for
like
all
table that was head, tail, that table.
Yeah, that you have to, not head, not 3 head should be there. Only we are, right?
No, I was talking about the vertical, vertically.
Vertically, okay. So you'll be having 8 rows, right?
8, yeah. On the first column there is 4 head and 4 tail.
Why 4? We are tossing it 3 times, right? How can I get 4 head?
No. If we will plot it vertically.
So he's talking about the 8 rows you're talking about. The first value in the all 8 rows.
I'll just tell you the one example. Okay.
Sir, can you please show the question?
Okay, also one second. I'll just try to see. You just have to plot the table with XY value. And the first outcome would be what? You'll be having 8 outcomes, right? The first would be head, or whatever you have been starting.
Yes.
Right? So
And
for
the second will be head, tail, head.
Whatever you want to tell, you want to say.
Yeah, that only thing I was telling, that the first head will continue to 4 head. We will write 4 head and then 4 tail.
Okay. 4
vertical.
4 head, 4 tail. Yeah, correct. You can write it in that way also. Okay, so yeah, this is the question. I guess I've explained it. If anybody is having any issue in the question itself, you can ask me. I'll try to explain it again.
Hello.
Yeah.
Sir, I'm not able to understand the question. Like, if the first head occurs on toss 2 or on toss 3, you score 2 or 3 points. That means if the first head means occur in the toss 2, then we will get 2 points. And if the first head occur on toss 3, then we will get 3 points. Right?
Yeah. So if you have got this one, tail, head. So for this you will get 3 points, right?
Okay. Got it.
Right?
Yeah.
And the head number of count of head is what? 1. So you'll get 1. So similarly, you can plot for all the 8 conditions, and then you'll be able to solve it.
I have just found out, like, we cannot make in that way, like X is a number of heads and Y is equal to 0.4. So range of X equal to can be 0, 1, 2, 3, and range of Y similarly we can find out, and we have to.
I'm just telling you to plot this table. From that table, you'll be able to know the range also, right?
Okay. Okay. But I have done in this range. I have in range of x, range of y. Then I am building that table.
Okay, so what is the probability you have calculated? The value of x should be greater than 1 and the value of y should be greater than equals to 2, right?
Yes.
So this is what you have to calculate. So everybody please try to calculate. This is not difficult, but maybe the language would make you suffer a bit, but just try to write the value of all the joint distribution, all the joint probability value for all the points. Just plot the table, write it all the values, and then you will be able to write the final value.
Can we go 1 minus also, counting that it is
minus 1, you can, yeah, you'll get 1 minus 1 also. If all the 3 are tail, then you'll be having -1 as y, right? Because
no, what I mean to say is, what is the probability that more than one head will occur, right? If I say 1 or none, will it be also the same thing? 1 minus probability of 1 or none occurring?
Can you repeat that? Can you repeat that? You are saying probability of calculating more than 1.
Probability of calculating more than one head is what we're actually looking at.
Okay, yeah. So you can do it in the both way. Either you calculate by 2, 3, or you can minus like 1 minus of 0, 1, 1.
Okay, okay.
Both way you can calculate.
Here, what is the possible number of the scores can be achieved?
The possible number can be what? -2, -2. I'm saying -1. It can be 1, 2, 3.
10.
0 can be there.
No, 0 can't be there, right? Either the number of heads should be there, or the number of their own. Either if the number of head is 0, then the value of y would be -1. Otherwise, every time some head will come, right?
Yes.
Some places. So the value of y should be
triple tail
there.
only it will be -1 for triple tail.
Yeah, for triple T, for triple tail, it will be -1. For all other value, there will be some sort of values from 1 to 3. And you have to calculate, you have to find out where the value of x is greater than 1, means x, where the values of x is 2 or 3, and where the y also you are getting more than 2. Means you have to do the summation of x equals to 2, 2, or 2, 3, or 3, 2, 3, 3, or 3, 2. So you have to find out how many, what?
Okay, we'll discuss during solution.
So everybody has tried to solve this one. If everybody has tried, I can.
I have a question again. Sorry. Even the entire table has to be plotted to get the.
Not see if you are having a good visualization, I guess without plotting the table also you will be able to solve. You can just find out when at which position and what are the values where you'll be having x will be when the number of head will be 2 or 3 and the point also will be 2 or 3. If you are able to think of that, you'll be able to solve. I've just told you to plot the table so that you can just know the values of all the things, and then you are not in the position to incorrect this question. Okay, visualization can be one method. You can just visualize and you can solve. Yeah.
Sir, I wanted to ask that, for example, we take the case 1 in which we get all the 3 as heads. So, sir.
Okay. Yeah.
So, sir, we'll take it as 1 point or 3 points. Like
1 point only, because you are getting, see what has been written here. Y denotes the point scored, and see means if you are getting the first head itself, so you'll be writing 1 point only. You don't have to add for all the heads. If you're getting the head in the first trial itself, you are getting 1 point. If you're getting the head in second trial, you'll get 2 points. If you are getting the head in third trial, you'll get 3 points. If you're not getting the head in all the 3 points, on the 3 trial, you will be having -1 points, right? Have you got the point?
Yes, sir, I got it.
Yes, sir. I've done it, sir. Please move towards the solution.
So everybody is done. Should I wait for 1 more minute?
Now let's move to the solution part, sir.
Okay, I'll just see the answer once. So everybody has written a different sort of answers. I guess there is some issue in. Okay. So, so this is a table. So everybody is having the same table, right?
Yeah. Yes, sir. I have it.
For 3 means what? The number of heads. So the number of heads 3, and we are getting the head in the first trial itself. So the value of y is 1. Here the number of heads we are getting 2, and we are getting the heads in the first trial itself. So the value of head y is also 1. So every time we are getting the head in the first trial, the value of y is 1. So what has been asked? So we have been asked x should be greater than 1, means x should be 2 or 3, right? So this 4 will get removed. We are left with this 4, right? And now y should be greater than equals to 2, means only this is the final
Only one
condition.
case, sir.
So this is the only one case. Okay. And the probability, if I'm having only one case, the probability would be 1/8.
1 by
right?
1 by 8.
How, sir? Can you go again, sir?
Okay. See, so for all the possible values, you have calculated the value of calculate the value of x and y, right?
Yes, sir. Yes.
Okay. So now you have been asked to calculate the probability such that x is greater than 1. X is greater than 1 means the value of x should be 2 or 3, right?
Yeah, 2 and 3.
This 4 is removed.
Yeah. So it will be 4 by 8.
Okay. Now you're left with 4 only.
Yeah.
Right. Now out of that 4, what was the condition of y? Y should be greater than equals to 2. That means y can be 2 or 3.
Okay.
So how many conditions are there? Only one condition. So this is the only a possible, or you can say the favorable outcome. So this is the favorable outcome, THH, and the probability of getting THH is 1/8.
Sir,
Right?
the score should be 1 plus 2 plus 3 plus, right?
No. The score, I've repeatedly told you, the score is not the addition of all the points. The score depends on the number of trials in which we are getting the head.
Yes, sir. Heads.
Okay.
First,
The
second,
score
or
is
third.
depending. Yeah. So it can be 1, 2, 3. Otherwise, I would have told you that the range can go from 6 till 6 also. Right. So yeah. So maybe
number of trials in which we are getting the first head, is it?
Yeah, correct.
Sir, can I see the question once?
But the question didn't tell that one, sir.
See, the question is 3 fair coins are tossed. If the first coin occurs in the first toss, you'll have 1 point. If the first head occurs on the 2 or 3, you'll be having 2 or 3 points, right? So you don't.
Okay.
We have not said the summation and anything. We have not said. Okay,
Sir,
so
this is the same question in graded assignment, sir.
Okay.
The question number 1.
Okay.
This
Cool
one.
then. Yeah.
Yeah.
So you'll be having. Sorry. So I'll go to the next one.
Sir,
This is the
can you please, sir, can you please just read out the table again? The 2 1 I just got confused there because the third one HTH. So we are getting 2 heads. So x is 2 and y is 1 because of 1 head. And the
because of
second one.
Yeah,
Yeah,
because
2.
what second one?
X is 2 because 2 heads I'm getting out of 3. Then y becomes 1, and the next one it becomes 2 heads, but here y is 2. That I got confused.
See, on the second trial we are getting head, right? That's why the value of y is 2.
Okay.
See,
As per that question information.
yeah. So the first trial we are getting head, so the value of y is 1. Again, we are getting the head in first trial, so we are writing y equals to 1. Again, the same thing, 1. And now we are getting the head in second trial, so we have written 2 points we are getting, right? In this problem, we have got in this element, we have got the head in the third trial, so we are writing 3. Okay? So I guess this is clear. I'll move to the next one.
Yes.
Yeah, marginal can't go over 1. So the summation of all the values of marginal should also be equal to. So this is the next
session is
question.
recorded, right?
What?
This session is being recorded, right?
This session will be there in the YouTube.
Okay.
Okay, so this is the next one. You can try it. We have more 15 to 20 minutes, so we'll try to this. And then if I've discussed the basic concept of the first week, again in the end I'll just discuss in 5 to 10 minutes, and then we'll move.
I have a question which is not from the ones you're looking at. Practice question assignment, practice assignment 1. The last question, can you help me with after this is done?
Okay, I'll do it after we are done with this. Okay.
Yes, please.
We have not covered the concept of week 1, sir. We have hardly written a couple of lines.
So week 1, we have just went through the joint PMA, marginal and conditional, right?
Okay.
And the marginalization.
Up to 2 variable and then more than 2 variables. So there are 2 cases.
Can you clear me one thing?
Yeah.
Here it is given that uniformly at random to one or more of 3 films. One or more it is given, but we have only 3 films A, B, and C.
So either A can get 1, or either A can get 0, or B can get 1, or C can get 2, right?
Okay.
The summation would be 2, but the value can vary, right?
Sir, I got it. Same table we have to draw, right?
You can draw the table also, but without the table also you will be able to solve this. I have solved without the table. I'll tell you how. So here what you have to calculate, you have to calculate the x given y equals to 1, right? So you have to divide with what? Marginal distribution of y, where y equals to 1, okay? So marginal distribution of y equals to 1 means what? X can vary from 0, 1, 2, right? Not 0, 1, 2, like for the 2, the probability would be 0. But mainly the x can be 0 or x can be 1.
Yeah.
Fine. For x equals to 0, y equals to 1, you have to calculate the probability. Do the summation with x equals to 1 and y equals to 1, right?
Yes.
For each the job, the probability would be 1 upon 3, right? Because we are having 3 forms. So 1 upon 3 would be the probability.
The range of A is 0, 1, 2.
Yeah, 0, 1, 2, fine. The probability is 1 upon 3.
It will have range 0, 1, 2.
What 0?
All 3 will have range 0, 1, 2.
A can have 0, 1, 2. B can also have 0, 1, 2.
Correct.
C can also have 0, 1, 2.
Yes.
And the probability of assigning one job to any one form is 1 upon 3, because we are having 3 forms, right? So what you have to do? You have to calculate the marginal distribution of y, where y equals to 1. Okay, and the joint distribution of what? X equals to 1 and y equals to 1. X equals to 1 and y equals to 1 means what? X equals to 1 means what is that x? X is the contract.
Film A has 1 contract.
Okay. So
should we start by assuming
and another contract is with film 2? Oh, sorry, film Y.
Okay. Yeah, correct. So what you were asking? Somebody was asking something.
Yeah. How would you actually construct the table in this context? Would it be A, B, and C, or is it going to be construction jobs 1 and 2?
So here we have been asked for x, y only. So x, the value of x can be what? 0, 1, 2. And the value of y can be what? 0, 1, 2. So you can plot it like this.
Sorry, y is x. X is the number of construction jobs, right?
X is the number of job that A is getting.
Yeah. Okay.
And y is the number of job
contracts that
y
B
is getting.
Okay.
Contract y B is getting.
Okay.
So the many of the time the probability will be 0, because 2 can't happen, because the total number of jobs is what? 2 only,
Yes,
right?
And 0, 1, sir, because
So for all the two
one,
cases, it will be 0. For all the this cases also, it will be 0. And
Yes,
for 1, 1, it will be something. 1, 1, what would be the value? 1/3 into 1/3 plus 1/3 into 1/3, right?
Yeah.
For 20, how come it is 0, sir?
20 because not 20, not for 20. Sorry, not for 20. For 2, it would be. For 2, 1, it will be, but not for 20. Sorry about that.
And 0, 2 also, how it is 0? 0,
No. For that also 0 to, for only for 2, it will be 0.
The first one, right?
First row.
Because it is written here that one or more of.
So even for 2, 1 and 1, 2, it will be.
No, for 2, 1, the number of job will become 3, right? But we have to give only.
Construct this table again.
So that could be 0, right?
What?
Can you construct this PMF table again clearly?
I'll construct it again. I'll do it again. Okay.
Because the similar question is there in practice assignment also. It's a little bit difficult to understand.
So this x and this is y. So x can take what? 0, 1, 2, right? Y also can take what? 0, 1, 2. For 2, 2, it will be 0.
Yes.
Whenever there is a summation, the summation is greater than 2, the value of probability would be 0. Have you got the point? So for everywhere, for 2, 1, it will be 0.
Yes, 2, 1 will be 0. 1,
this
2
also will be 0. For this you have to calculate. For this you have to calculate. For this you have to calculate. But here we have to calculate only for 1, 1, right? Because here it has been asked for x, y, 1, 1, and you have to divide it for this one, right? Fine.
Yes.
So this how you have you calculate. This should be what? What is the probability that if I'll say if the work is the first work is some sort of A. See, for example, the type of work is what? The type of work is some small a, and the type of work one is small b. So either A can go to the A also and B also, right? And this also can go to the A and B also. So the work can be what? AB or plus BA, right? So 1/3 into 1/3 plus 1/3 into 1/3. Because 1/3, why 1/3? Because we were having A, B, C, all the three.
Yes.
Right? So you should not get confused only 1/3 and 1/3 only. Because again, you have to take this also, BA. So the type 1 work can go to the A also and type 1 work can go to the B also. Because we are having two types of work. Are you getting my point?
Yes, sir. But when we are constructing this joint, hello.
Yeah.
Yes, sir. When we are constructing the joint PMF table, we were just multiplying the thing. We're not caring about
multiplying. When we were multiplying, when the things are independent, right? Here the things are not independent. You have to think and rethink what would be the probability when x equals to 0 and x equals to 1 and y equals to 1.
Okay.
The table simply is when x equals to 1, y equals to 1, what is the probability of that? This is not the multiplication of both the things. If every time the multiplication will come, every time we can say this all the conditions are independent ones, right? So this will not occur every time. For the coin cases, it will work many a times, but that also depends what's the random variable has been defined there.
Okay.
So I guess this point, so x equals to 1, y equals to 1, you have to calculate, and then you have to calculate the marginal distribution of y, where y equals to 1. How you will calculate that?
It's just f of y equals to 1.
Okay, I'll just delete it. Okay, so see, now you have to calculate what? You have to calculate the marginal distribution. Marginal distribution means what? You have to fix the value of y1 and the x can vary. So what can be the x value? X, we already know x can vary from 0, 1 and 2, right? So the probability of 0, 1 or probability of 1, what is fixed there? 1, 1 or the probability of 2, 1. This is 0, right? Because the sum is coming 3. Fine. This we have to calculate. This we have calculate what? What was that? 1 upon 3 into 1 upon 3 plus 1 upon 3 over 1 upon 3. And similarly for this also, we'll be calculating 1 upon 3 into 1 upon 3 plus 1 upon 3 into 1 upon 3. So you'll get what? 2 upon 9. And you will get what?
For 0, 1, why are we considering twice? 2 by 9.
Okay, where? Here.
0, 1, yes, yes.
This is also same thing, right? 1 second, I'll just try to solve.
Sir,
Yeah.
when when the probability of 0, 1, so when x is not taking any value, then the probability should be 2 by 3, since x is not taking any value. I mean, a is not getting any job.
I also think so. Shouldn't it be 2 by 3?
Here, this one.
2 by 3
Yes,
into
sir.
1 by 3.
See, 1 by 3, what was the probability? That's 1 by 3 is what? Okay.
Probability of getting a contract.
But that was uniformly for, like, for example, I'm having this one sort of type 1 job. Okay. This can go to A, B, and C. Right? And for this, the value would be 1 upon 3. Okay, 1 second. I'll just go through the solution. Oh.
Sir, you can write it this way, sir. Uniform 0, 1, 2. That means
This 0, 1 is really confusing how to understand.
job is uniformly distributed.
Yeah, job is yeah. So there it is
Uniformly, and yes, sir. Job
is randomly assigned to one or more of the 3 forms. So the possibility,
Yes,
the probability of assigning one job to any of the 3 forms is 1 upon 3. Okay.
Yes, sir. You can write it as X uniform 0, 1, 2. So the probability of getting 0 is 1 by 3, 1 is 1 by 3, 2 is 1 by
2
3.
is also 1 by 3. Okay.
Yes, sir.
So that is how it has been written for x equals to 0 and y equals to 1 also.
Yeah.
It has been written 1 upon 3 into 1 upon 3 plus the same thing, right?
Yes. Yes, sir. Yes, sir.
Yes.
Yeah. So, and the joint distribution 1, 1, you can directly calculate. That is 2 upon 3. So if you'll divide it, you'll get, I guess, 2 upon 9 upon 4 upon 9. That is 1 upon 2, I guess. Yeah.
Just out of curiosity, what will be P of x is equal to 0 and y is equal to 0?
That will again be the same.
Same as in, please.
2 upon 9.
2 upon 9.
Because
the jobs are both getting assigned to C. Is it the reason?
X0, sir, how it will be 2 by 9? Because X0 and Y0 means C is not getting any of the job, right? How it will become 2 by 9?
Wait.
2 by 3 times 2 by 3.
Sir, can I speak one thing, sir?
Yeah.
Okay. So I think we should go again with
Look, but one thing I want to say, please listen. If you are throwing a dice, okay, then there are six outcomes, 1 to 6, and probability of getting 1 is what? 1 by 6. That means 1 to 6 is uniform. You are getting the probability. Think that way. You are getting a job 0, 1, 2.
See, this you can think as 1, 0, 1
by 3.
0,
Yeah.
1, 2, 3. You can think this 3 as a 3 different, what you can say. In the dice,
Yes,
you are
sir.
taking 6 things, right? So you can just imagine a dice with 3 triangular dice with the outcome as 0, 1, 2. And the getting of 0 is also 1 upon 3. And getting of 1 is also 1 upon 3. And getting of 2 is also 1 upon 3. Right? In this way, if you are thinking, you will be able to get my point. I guess.
This is clear, but why 1 by 3 into 1 by 3 then?
1 by
3 into 1 by 3.
1 by 2.
1 by 3 into 1 by 3. 1 by 3 into 1 by 3.
Okay, 1 by 3 is for, see, because see, A and B is there.
Yes.
Okay, A and B means X and Y, right? And for that A and B, we can write, see, simply type 1 and type 2 is there. Type 1 and type 2 is there. Fine. This can go to A and this can go to B. That, for example, 0 1 is there. Either this 0 1 can go to here X and 1 can go to Y, or the opposite way. Right? So 1 upon 3, 1 upon 9 is for one cases and 1 upon 9 for the reverse cases. Every time we are reversing everything, right? So 1 upon 9 is for one cases and 1 upon 9 for other cases. So the summation would be 2 upon 9.
Sorry
Right?
to interrupt you, Vishal. If you won't mind, can you make this PMF for this and can we submit and make it as 1? Because I
Yeah, it'll
tried
be
for
really
the
helpful.
PA question, I'm not getting 1. The sum of joint distributions.
Okay.
I might be making some mistake somewhere, I don't know, especially this question.
Sir, how
If you
many
have
questions
time,
are
please.
remaining?
What?
Sir, how many questions are remaining, sir? Because it's already 8. There is one more session, sir. Mathematics.
Okay. Okay. So, okay. In the end, we'll do. There is only one question. Just solve it, and then we'll try to
Yes,
do
sir.
it in the
Yes,
end.
sir.
Okay.
Yeah,
Is that
on this question,
Yeah.
why is it that 1 1 is 2 by 9? I'm not clear on that. Maybe I will continue after 8 o'clock also. Hopefully, you can
Yes,
spare
we'll do
some
at
time.
the end. We'll construct the PMF table at the end. That's better.
So what is the answer
Yes,
to
yes,
this
sir.
question?
First,
It's half, right?
1
please
upon 2
solve
is
the
the
question.
final answer, and then this is the final one. Just try to solve this. This is the
Okay,
final
sir.
question of
Okay,
today's.
sir.
Sir, could you just show the previous answer just once?
When you will be uploading this one in this portal?
1 upon 2 is the final answer.
Just a second. Just a second. Sir.
Sir, when you will be uploading this one in the portal?
I'll just try to send it now itself, but I don't know whether it will upload it today or not. But tomorrow morning it will upload.
So one small doubt in this question.
Yeah.
So you said like 1 by 3, we are doing that addition because any job can be assigned to I mean it can be in the order of A, B or B, A, right? So
Yeah.
that's the reason we are doing addition. Is my understanding correct?
Yeah, yeah, fine.
Okay, okay.
Okay, sir. Let's move ahead.
Yes, sir.
The answer is 1 by 2, right?
Answer is 1 by 2. This is the final question.
So this just happens 2 times, right? Means first time the coin is tossed for 6 times, and suppose we get 3 heads, then it is again tossed for 3 times.
Yeah, yeah, yeah. So the second thing is the conditioned over the first one.
So, but in the next 3 tosses, if we get 2 more heads, then it will not be again tossed for 2 more times, right?
Yeah, yeah.
Or it will be.
What?
So suppose the coin is tossed for 6 times. Okay, we get 4 heads in that. Then the coin will be tossed for 4 more times.
Yeah, you're right.
Now in those 4 more tosses, if we get 2 more heads, then will the coin be tossed
No,
for
no,
2
no,
more
no.
times?
No, no, no.
So the process will repeat only 1 time, right?
Yeah.
Sir.
Yeah.
Sir, I just want to ask one thing, sir. Then after I will leave, sir. Sir, I want to know just we will get this possibility only in the two cases. Huh?
Which possibility? This possibility. Find the probability
yeah.
that the head will appear
sir.
for the total of 5 times in this process.
Yes, sir.
Is it 5 times out of 6 or 5 times out of the entire 30 times?
5 times?
30 times? 6
Out of
times.
entire,
Basically, you are
times entire-
saying the fair coin is tossed 6 times and the number of heads is counted. The coin is then tossed n more times. Oh, sorry. Got it. My mistake.
6 plus n.
Yes, sir. I was telling that this will happen in two possibilities.
The first case is the binomial of 6, right?
Yes, sir.
The second case is also the binomial. The second case is the conditioned over the first case with binomial n, and n is the value of head, whatever you are getting from the first 6 trials, right?
Sridhar, I think it will be 3 cases, 3, 4, and 5.
Yeah, there will be 3 cases. Yeah, 3 cases.
Yes, there will be 3 cases, 3, 4, and 5.
Yes, 3, 4, and 5.
Hello.
Hello.
Yeah. So I guess only 8 people have solved. Okay. Should I solve this or? Okay. So the fair coin is tossed for the 6 times. Okay, and the number of heads, whatever the numbers of head you are getting, again you have to toss the coin for that n number of times, and we have to calculate the probability that the head will appear for a total of 5 number of times. So how can you get that? So just we'll start with 1. If you are just getting the 1 head, and again if you are tossing the coin for the 1 time, that will not make any impact, right?
Yes, sir.
So it will start 2 also will not do anything, because if you are getting the 2 heads also, and again you are tossing the coin for the 2 times, you'll get maximum 4 heads, right? So you'll have to start with 3, right? So if you are getting 3 heads out of 6, and then if you are tossing the coin for 3 times, and out of that 3, if you are getting 2, that is a 1 possibility.
Right.
Fine. So similarly, you have to think for the other cases also. What are all the other cases? Can somebody speak out?
There are many actually.
3, 4, 5.
Not there.
No, even four tosses,
4,
2 heads,
5,
then
6.
again 4 tosses, 3 heads. Likewise, 4, 3, 4, 2, 4, 4, 4, 1, like that.
Okay,
No,
so one
only
I have
three
told
cases.
you, one I have told you, 3, 2. One I have told you. The other is
2, 3. 4 tosses total, but 2 heads
3
and
with
then
the
3.
4, 1, 4, 1.
Because 4 tosses and I got 2 heads, and after that
1,
again 4 tosses.
5, 0.
Oh, sorry,
5,
2
0.
2 heads.
5, 0.
My bad.
Only 3.
okay.
Only 3
and
options. 3, 4, 5. Yes.
anything more than that? Anything else? 3,
No, sir.
nothing, right?
Yes, sir.
So you have to calculate the probability for this one. Fine. So you have to calculate the probability for these 3 cases. How will you do that?
Yes, sir.
How will you do that? Who is this? I'll try to mute everyone. Okay. Okay. So
Sir, will it be like this? 6 choose 5.
Hmm.
And then
Okay.
1 by
See.
2 to power.
Okay. So, when x equals to 3 and what is this? N equals to 2. How will you calculate the probability of this? So for you already know this is a binomial. This is a conditional or binomial, right? The condition double binomial, right?
Yes.
So how will you do that? How will you write this?
So is it like
6 choose 3?
Yeah.
Choose 3
Okay, 6 choose 3 and
3
1 upon
into 1 by 2 bar
6.
what you will write for this?
Into 3 choose 2.
Into 3 choose 2.
Yeah.
3 choose 2.
1 by
And
2 to power 3.
3. Yeah.
Yeah.
Plus
Correct. This for this one, and again you can write for this one also.
6 choose 4.
Similarly, you can write for this, right? And again you can
Power
write for this
6.
also. 6 choose
Power
1 upon 2 to the power 6, right? And then here also you can write 4 choose 1. 1 upon 2 to the power 4, and here you will choose 5 choose 0 and 1 to the power 1 upon 2 to the power 5. Any problem in this?
the answer is a little complicated.
Okay, you have to, the answer would be 0.17 some, right?
I'm getting 0.35.
So maybe some error is there.
Sir, could you solve it,
0.18.
please,
Yeah,
sir?
this is correct. Atul Goswami has written the correct
Sir,
0.18.
could you please solve it, sir?
I'll solve it.
In physics also, I am facing the same issue. Till here, I am able to get, but doing errors in the calculation after this.
Okay, so whatever till now we have told, you have done the same thing. I guess you only told me the solution, right? So till now you have done the same thing. Like, have you got the point how we are getting this 3?
Yes, no, I'm telling it solving the expression what we got C2, C3, right? Solving this.
Okay, so this is
Ending up with some errors and
So this is 633, 1 upon 2 to the power 6 into 3, choose 2, 1 upon 2 to the power 3. Plus, this you have to do this summation part is a bit hectic right here.
Now we are able to do because we have plenty of time to do, but in the quizzes, the main issue arises. In hurry, we'll do mistakes.
Yeah, but the quiz won't be having this sort of question. This sort of like the concept by in point of view conceptual, it will be there, but the calculation part won't be much. But in the stats too, we generally provide the formula, we generally provide everything we provide in the stats too. We'll provide all the formulas, whatever you have read, all the basic, all the formulas. So you don't have to remember also. You'll be having all the formulas in the answer questions itself.
So next one will be 64.
Yeah, the next one will be 64, 1 upon 2 to the power 6 into 4, choose 1.
4C1, right?
1 upon 2 to the power 4. And the next part would be 6C5, 1 upon 2 to the power what?
6.
And 5, choose 0. 1 upon 2 to the power 5, right?
Right.
This you have to do the summation.
Then we'll have to solve it. Okay. Can we come back to previous question, sir?
0.178.179 is correct. Around 0.18 would be the value. So I'll just go through the solution. If somebody
Sir, is this the last question?
Yeah, this is the last one.
Okay, sir, then I'll have to leave for maths. Thank you.
Okay, so whoever wants to leave
So
can
now
leave.
can we come back to previous question and discuss the PMF table?
Yeah, so I'll try to discuss it. Whoever has the math session can go. I'll try to discuss it. Okay. So this question is done, right? So we'll come to the next part, the remaining part. Okay.
Are you explaining this question, or are we allowed to ask other questions?
I'll just explain it.
Okay. Okay.
If you are having any other issue, you can ask me.
Yes, the practice assignment questions, I just wanted some support.
Okay, so what you can do, you can mail me. I'll just create a Google link, different place, and we can discuss it there. Will that work, right?
So can you go to a solution?
If you have a little bit of time, I don't mind waiting around also. That's not a problem either.
Yeah, so I'll just, 1 second, I'll just tell them to stop the streaming and then we'll try. Yeah.
Just before going to final questions, we were discussing, the semi-last question, and we discussed that after this question, we'll discuss the PMF table of that one. So can we discuss that?
Yeah, sir. Please discuss PMF of previous questions.
Okay, this one only, right?
Yes.
Yes, sir.
Yes.
So how we get px is equal to 1 and y is equal to 1? Like why we added that part?
Okay.
Actually, Vishal, I want to construct the PMF and to make it sum as 1. I'm trying for that. I'm not getting for this jobs question.
Okay. So I'll try to do that.
Yeah, please.
Yes, sir. Just make the table and show us.
Because if you do that, it will clear all the concepts all at once.
Okay. So this is the fourth question. Yeah. And the fourth question is, so we have to calculate, we have to plot the table. But the x is what? Here, this side x equals to 0, or x can take 1, or x can take 2, right? Or y can take 0, y can take 1, and y can take 2. So, Okay, so 2 will be 0 and then 2 1 also will be 0. 2 0, 2 0 is what? 2 0 means both the work went to the X.
That's okay. It works.
So PQ is the job. So both the PQ went to 2. So 1 upon 3 into 1 upon 3, right? This should be 1 upon 9. Fine. And again, this also will be 1 upon 9. This will be 0, right? Fine. This will be the PQ or QP. The both are getting, can be, albeit there is some.
For 0, 2, so getting not getting job also we are considering as 1/3 only.
Yeah.
Because getting job is 1/3. Then how come not getting job is also 1/3?
See, whether if somebody is getting X equals to 0, 1 and 2, this is uniformly distributed over ABC. So not getting is also 1 upon 3, getting 1 is also 1 upon 3, and getting 2 is 1 upon 3.
Okay.
Sorry.
This is what been written, right? This is what been written.
I thought the earlier discussion, it was about getting a job of contract 1. The possibilities between among A, B, and C is 1/3, 1/3, 1/3. Now, if you put it that way, it is going to be a little different, isn't it? Company A getting 0, 1, or 3, with 0, 1, or 2 jobs. All of it is 1/3. How come?
Yes, sir.
Okay.
That's the confusion. Normally, as of now, we are doing getting job is 1/3.
Once again,
then not getting job is 2/3. We are considering.
What you've been considering? Okay, you have been considering.
If getting job is 1/3, then not getting job is complement of it, and it will be 2/3. Like that, we did as of now.
Okay, yeah, okay, maybe I can read. Contract for 2 construction job are being signed uniformly at. Okay, yeah, you are. I guess you are doing the correct way. I guess.
Sir.
Yeah.
Is it because when A is not getting a job and B is getting a job, it means C. If A is not getting a job, that means C is getting it. C and B are getting a job. Something like that.
Yeah, this is clear. If C is the total number of job is 2, right? If C is getting some like 2 jobs, then A and B will not get anything. What is the sample space? A, B, C, C, B. What is this? Nickel.
It would be good if you really map out with the steps,
Yeah, I'm trying to do that. I'm trying to do that.
Let's talk about the number later. At least we'll understand the logic.
There is some error in the what has been for 2 construction job are each assigned uniformly at random to one.
You started with an arrow diagram. Now, why don't you try it again?
See, this is P and Q, right? This is the one type of job, and this is the different another type of job. This can go to A, this can go to B also, this can go to C, right?
Yep.
Yes.
This also can go to A, B, and C.
Yep.
Fine.
That's case 1, and let's go for the case 2.
So till here it is clear. And now if X is getting 1 and Y is also getting 1, right? So X is getting 1 means what? Okay, so we were X is getting 2. So both the 2 cases are here. So 1 upon 9, this is fine. Yeah. And I guess this should be 0, right? Because X is also not getting any job. So I guess this is not the correct procedure. For X equals to 0 also 1 upon 3. So we have to fix with the job. Like if I'm having 2 jobs from the starting, so I'm having 2 jobs, right? So please help me out if I'll do any error. So if I'm having two jobs, right, P and Q, fine.
Yes.
And two types of jobs are here. So, and P can go to A, B, C, all the three, and Q can also go to AV3, right? So if
Yes.
X equals to 0 and Y equals to 0 means X is not getting either of the P or Q, and Y is also not getting either of the two. So it will be 0, right? The probability will be 0.
So,
Fine.
but it means both the jobs are like C getting both the jobs, no?
Yeah, C is getting both the jobs. So we are not bothering about the C. We just focus on X and Y, right? Fine till here. And if X equals to 1 and Y equals to 0, that means what? Either P has came or Q has came, right? Is it fine?
Yes.
Or only if P
Sir,
has
in case
came.
of X,
But
either P or Q is getting the job, right?
Okay, if we actually go by that it is either of the jobs coming, then it is not a multiplication, it's the addition, right?
Yeah, so we'll do the addition, right?
2 by 3.
Okay, you fill the table as per your assumption. Let's see, will it sum up to 1 or not first?
Then it goes to 2 by 3.
Fine. So if I'm X is getting P, or he can get Q, right? And for getting P and P is going to 1, P is going to XA is what? 1 upon 3?
yes, sir.
Fine.
Yes, sir. And then for, we add for the Q now.
1 upon 3.
Plus 1 by 3.
By 3. It's 2 by 3 then.
2 by 3.
Okay, then it's 2 by 3. Fine. Okay. And again, if I'm doing for the X equals to 0 and Y equals to 1. So what is this? This is
also 2 by 3. Sir.
Again 2 by 3.
Yes, sir.
Because there is some error in the questions or what? The question is written. The
And it will
context
be greater than 1 now.
number of what is this? Number of possibilities in which two jobs are awarded to three firms is 6. Number of possibility with which, what is this? Two jobs are awarded to three firms. The type of, okay. Okay. So what he is saying. So once again, if I'll just go with, I also am getting a bit confused here. So if I'm having, what was that? A, B, and C.
So can we go with the multiplication rule, like 2 jobs and 3 row, like 2 into 3, 6?
It depends on whether it is a mutually exclusive event and you can multiply the probabilities. It is not just about addition.
And this is A and B. The job is what? P and Q. So the
No, so like in the stats one, the multiplication rule, we have two like jobs and 3 companies. So the total number of cases will be 6.
yeah, that is fine. Okay, so if you are asking, so P can have A or A, B or AC, right? And similarly, Q can have what? The same thing again, right?
Yes.
No, all the 6 combination would be what? AB, AB, AC, and then
There will be 9 combinations if it is AA, because AA, AB, AC, BA, BB, BC.
So
and
BA
CA,
and AB would be
BCC.
same. Okay, and then what is that?
BA,
What is
BB, sir, for
BA, BB, CC, BB, BC.
BC.
BC. And
And then it
similarly,
will be CA,
CA, CB, CC.
CC.
Okay, so this is same.
Similar, so yes, sir.
This is 1 upon 3 into 1 upon 3. This is okay, fine. So this is similar, right?
Yes, sir. So the total number of sample space will be 6 only.
And this is similar.
Yes,
So
sir.
this both is same.
And CB is equal to BC.
Similarly for BC and CB.
Okay, and this is also same. So we'll be having only six.
Cases.
So AA. What is
AB.
this? AB or BA. Okay.
BC.
AC.
BC.
Okay, AC and then BC.
Yes, sir. BB and CC. Previously, we were counting like 2 times, no?
Yeah. So now, so we are considering in a different way now. So A can have this. Okay, nice, fine. So how will you calculate the probability now? So this is 1/3. This, sorry, 1/9. This is 2/9. This is also 2/9. This is
Mine
also
are 1/6, sir. If we are considering those two identical.
Yes, sir.
this.
In this case, the whole probability will be equal to 1, na? Like 3 cases for 2/9 and 2 cases for 1/9.
Yeah, fine. So this is also 1 by, what is this? 1/9 is 1/9. So the 4 cases are 1/9 and 3 cases are, sorry, 3 cases are 3/9 and 6 cases are 3/9. Okay, fine.
How will be 15?
It's okay. With ABC, it's okay.
ABC, we are able to do this, but with this process, we are not able to do that.
I tried a lot this one.
Sir?
For
Yeah.
X is equal to 0.
Yeah, say.
Okay, so in the point CC, that point, can we consider that both A and B are 0? For point B, we will consider B equals to 2. For point BC, we will be considering Y equals to 1 and X equals to 0. Similarly, for point CC, if we consider X equals to 0 and Y equals to 0.
Yes,
this is X equals to 0 and Y equals to 0, 1.
It means both the jobs will go to the form C.
Yeah.
So
This
we
is X
just
equals to 0 and Y equals to 0 only. This one.
Yes, sir.
Yeah.
Am I audible, sir?
Yeah, you are totally audible.
Sir, the case in which C as our daddy comes 2 times in 6 possibilities. We are conditioning on C is equal to 1, in which A should also have been allocated. So that is only C, a combination of CA and CB, in which we have to choose only CA. So it comes to 1/2.
What you have said, I didn't got your point. Maybe okay,
So
can you repeat that?
C got our data exactly 1 times.
Okay.
In the 6 cases, there are only 2 cases in which C has awarded 1 contract. That is
fine.
AC and BC.
Fine,
Now we are interested in A getting 1 contract, given that C has 1 contract.
Yeah.
Okay. The given part is 2.
Upon 9.
No. In terms of sample space, sir, there are only 2 outcomes which satisfy.
Yeah, fine. Yeah.
Out of these 2 outcomes, only 1 outcome satisfied A and C.
Okay, then you can directly write.
You can directly say that 1/2 is the probability of A, C.
Yeah, fine. But if we are able to, okay, with this approach, you are able to solve. Yeah, fine.
Yes.
Okay, from the starting, we are doing it incorrect. So this was a good approach. With this, we are able to solve. So this is a bad approach. Or there will be some other, like, there will be a method to solve with this approach also.
It was very complicated.
Yeah, this was very complicated. So I started only. So my bad. So this is wrong. Not wrong, but maybe we can solve it. But there are so many complications. With this approach, maybe
we have to find joint probability of 3 variables, sir, by that joint probabilities approach. We are only taking consideration into 2 probabilities. We have to find P of A, B, C. and then marginalize.
Yeah.
That's why that was complicated.
Yeah, so sorry for that. We have taken so much time in that question.
Okay, can you please repeat what he explained? For me not clear, please.
This approach.
No. Just now he was telling something, no?
Can you repeat it again?
Yes.
Yeah,
If,
you can.
if we have to calculate solve the question with joint probabilities approach, we have to consider joint probabilities of 3 variables, means A, comma B, comma C. And we are only playing with 2A, comma B approach. We have to consider 3 probabilities. No, sir, we have 3 variables.
Yes.
So joint probability will be of P of subscript A, comma B, comma C.
Can you please write,
And
Vishal,
then,
what he is telling? Can you please write? Because can you make it?
Okay.
I'm
So
unable to get
I'll
it.
try to write.
Yeah, please.
Okay. So what was that? He's saying that. Okay. So why this? You have asked why this approach has not worked, right?
Yes.
Is this you were asking?
No. He was explaining some method how to solve it easily.
No, I was not explaining.
Okay.
I was not explaining. I thought that if we wanted to solve a joint probabilities approach, then we have to consider joint probabilities of 3 variables together.
That's what
and that would have been too complicated.
Yeah. So
And
that is what we were doing. That is what we were doing the mistake in the first approach.
Yes.
We were not considering y, and just with the x equals to 1 and y, like with the x and y we were trying to solve, right? So I guess
we have to try by ABC.
That's
you
why
can
we
solve
tried
this
with
problem and paste the answer. This case.
What can you repeat?
You can solve it and paste it on in this course. You can solve it later.
Try. Maybe I will
Can we try it now, Vishal? Because it's really a little tricky question.
Okay, so which method? Is this method or the earlier one?
Whatever it is, but I want to know
all
the joint PMFs of AB jobs. 0000110 especially.
Okay. So is this method fine, or can I explain it again?
Fine. Anything is okay. Just we want to solve this question and to know 0, 1, 1, 0 cases, especially probabilities.
See, so this was the 6th combination we have got. So 2 jobs are there. So the first job itself has got went to A. The second also went to A, right? Or this can be this one, AB. There are 3 forms, A, B, C, right? And then one is went to the first job went to A, and the second job went to C. Similarly, we can write all the combinations. So we have written all the combinations. So either it is A or B. So the number of, if we are writing AB or we are writing BA. So the number of jobs that is going to A is 1 here. In this case also, and in this case also, the number of jobs going to B and A is 1, right? So that's why this is the same one box. Okay. And again, if I'm C, B, and C, that means one job is going to B and one job is going to C. Fine. Similarly, we can write all the things. We can write CB is also 1.
I want to know that case when 0 job for A and 1 job for B.
Okay. So where is that 1 job for B? What you are asking, 1 job for B and 1 job for A.
0.
Yes.
So this is 1 method. This is 1. So here B is getting 1 and C is getting 1. That means A is not getting anything, right?
Yes.
So here for B, C or CB. So for this 1/3 and for this 1/3. Sorry, 1/9 and 1/9. Right?
Yes.
See, for we were having 9 conditions, 9 things, A, B to A, B, AC.
Okay, with this approach, can we make PMF?
Okay, yeah, we can make
We'll
PMF
check,
for
will it
this
sum up
approach.
to 1?
Yeah, so yeah, that will okay.
Yeah, we'll try.
It will come to 1.
Yeah, it will come to, see.
It will come to 1 because you are deriving it from, you're deriving the numbers from the what you are considering as a joint probability. So it's
X
going to
equals
come.
1, X equals to 2, right?
Yes.
Okay, now Y equals to 0, Y equals to 1, and Y equals to 2,
Yes.
right? So what is the condition when X is not getting any job and B is not getting any job? What is that? This is BCC, right?
Yes.
This means what? 1/9. Fine.
Okay.
What is the condition when X is getting 1 job and Y is not getting any job? So what is that condition? X is getting 1. Where is that? X is getting 1, yeah, and Y is not getting. This is this condition, right?
Okay.
Fine. Similarly, you can write, so for this condition, there won't be anything. So for this condition, this is 1/9, right? Am I writing correct, right? Okay.
Yes.
For
Yes.
this one, X is equal to 0 and Y equals to 1. This is this condition, right?
0, 2, Y it became 0. Y equal to 0, X equal to 2.
Sorry. Y is for what is that? X equals to 2. This condition. This condition 1/9. Sorry, that's my bad.
Yes.
Fine. Again, Y equals to 1, X equals to 0. That is what? That is, yeah. So B is getting 1 and C is getting 1. That means A is not getting anything, right? So for this also we have 2/9. Fine.
Okay.
X equals to 1 and Y equals to 1. This is this case. So we are getting 2/9. For this will be having 0, right? 2 and 1
Yes.
can't be there.
Yes.
2, 0, what is that? 2, 0 means BB. 2, 0 means BB means 1/9. Similarly, 2, 1 can't be there. And 2, 2 can't be there, right? So the summation will be what? 1/3, 1/3, 1/3,
So in
and
first case, Y is 0 and X1 will be 2/9, na?
Then it is 8/9, sir. It is not summing to 1.
8/9 only.
It's 8/9.
Oh, so
And
where
then
we are doing the mistake?
Y is equal to 0 and X is equal to 1. You have written 1/9. Here it will be 2/9, sir.
Where?
Sir, Y is equal to 0, X is equal to 1. In the first row, second term.
Okay, yes, this one.
2/9,
So
sir.
Y equals to 0 means we are not having anything.
Yes, it's
And
sir AC and CA.
AC, yeah. Where is that? Yeah, CA. CA is also there, right? So we'll be having 2/9. Right? So this is how we are getting 2, 2, 2, 6, and plus 9. Plus 3 is 9.
Okay, so we should consider C also while making the table for
Yeah,
AB.
because why we are considering, because C means A and B are not getting anything. At that point, X equals to 0 and Y equals to 0.
This, you can't skip that one, na?
And was
Okay, my question is, okay, let's say we got it. Now we are actually looking at conditional for X is equal to 1 when Y is equal to 1. So we go by Y is equal to 1, we compute, and then we go for X is equal to 1 when Y is equal to 1, is it?
Yeah.
Okay.
I guess we in the starting we were considering 0, 1, 2 as 1/3. That is why we were doing a mistake. But in this process, we have concluded. We have just divided the job for all the forms. So if you have right, earlier we were doing 0, 1, 2 as a uniform distribution. That's where we were doing the mistakes. So maybe this is clear, or I can solve it again, but I guess this.
So let's just check the answer with the help of this PMF table of that question.
What PMF table?
So with the help of this table, let's just check the answer of that question, the question number 4. No?
It answers, madam.
Okay, so what was that? What we have been asked to calculate? So we have been asked to calculate what?
No one can calculate anything.
Y is equal to 1 for X is equal to 1.
Okay,
Condition
so Y equals to 1 and X equals to 1. That is what? This 2/9, right?
Yes.
This is 2/9.
Sir,
And we have been asked, yeah.
We are asked as a probability of X conditioned Y is equal to 1 for X is equal to 1. Like
X conditioned Y equals to 1 and
X is equal to 1. 1x1. 1,
okay.
Sir.
So this is what? This will be XY 1,
yes.
1. This is 2/3, right? And this will be Y. So this is what? This is fixing a value of y as 1, fixing this and do the summation.
Yes,
So
sir.
I'll
4 by
fix it.
9.
So this is what? 4 by 9.
Yes.
And this is what? This is 2 upon 9. So we are getting 1 upon 2. Fine?
Yes.
Yeah. Okay. So is it clear or should I explain it again?
Clear.
Yeah.
Can you please show the previous page with cases? I will take screenshot. Yeah, this
Okay.
one.
Yeah, this one. Okay, you can take the screenshot.
Yes, that's it.
Sir, the maximum value a marginal or conditional or the joint probability can take is 1 now.
Yeah, the marginal, the summation of all the values. These are properties. So I'll just write all the conditions here. This is the joint distribution, joint PMF. So this is the fourth thing we have read in the first week. So I'll write all the formula. Joint, you already know, fx of y, t1
Yes.
comma t2 is what?
Yes, sir.
This is simply the probability of x equals to t1, comma y equals to t2, right?
Yes. Yes, sir.
Okay. And here the properties is what? Property is the summation of all the values, okay, should be for x belongs to t1 and y belongs to t2. The summation of all the things, all the element of that table should equals to 1, right?
Yes,
this is
sir.
the one condition. Again, we are moving to the marginal. Okay, so you can see with this example. See, for the marginal y equals to 1, what is the value? So for the marginal y equals to 0, it is what? 2 upon 9, 1 upon 9 and 1 upon 9. This is 4 upon 9.
Yes, sir.
Y equals to 1 is what? 4 upon 9.
Yes.
Y equals to 2 is what? 1 upon 9.
1
So
upon
the
9.
summation is what? 9
Yes.
upon 9.
Yes, sir. 1.
Right? So the marginal distribution also the summation would be 1. Again,
Yes.
we can do the same with the x equals to
1.
1. If we are
Yes.
fixing x equals to 0, what would be the value? 4 upon 9. Fixing x equals to 1, the value would be 4 upon 9. And again, fixing the x equals to 2, the value would be 1 upon 9. So we can do the summation, we'll get the marginal distribution as 1, 1, right?
Yes, sir.
For all the cases, we'll be having this.
Okay, sir.
Probability was seldom brought. This is I've not read fully, but I've went through for some problems and all. This is a good book. I guess they would have provided in the portal 2-3 books would be there, right? You can practice some questions, but I will tell you to not go there and there. Just practice the activity practices. And if you're having any issue, you can ask us, like you can mail me or any other. We'll try to solve. Like there's no one perfect, but I'll try to solve all the cases with you. Maybe we can discuss it on the Google, like try what you can say, some Google link and all.
So are you going to take a class tomorrow, sir?
What?
Are you going to take a class tomorrow?
Tomorrow I'll not. I have a flight tomorrow. I'm going to Chennai for that fest. So, so tomorrow I'll be totally busy. So day after tomorrow I can take. But if it will help you because tomorrow also you have the submission. If you're having doubt till tomorrow morning, you can ask me. I'll be here. I'll try to solve and send back to you. Okay.
Yeah. Just if I can make a request, can you solve this practice assignment question 9, please? It is something to do with conditional probability, but I'm not able to break it. Probably it is too simple, or I don't know. I don't seem to be getting.
Well, probability is a bit complicated. So when somebody has solved thousands of problems, he'll be facing a problem when he's solving 1,000 and first solution. So yeah, this is the
any good book to solve more and more problems, sir.
This don't solve more and more problems. There is much of the problem in the we are providing. There's so much of problem.
Would you be able to look at this practice assignment question now, Vishal?
Okay, I'll try to open that.
Yes, please.
Can you mail that question? I'll try to solve after like having dinner, having a bit hungry.
Okay.
Is that fine? Can you mail me that?
I'll mail you the question right away.
I'll pakka solve and send you. Okay. Or else we can discuss it tomorrow morning.
Yes,
also.
yes.
Okay. Anybody?
Tomorrow you are taking the class?
No, I'll not take the session tomorrow.
Okay.
Because I'm busy. So maybe day after tomorrow I can take. But if you guys want for week 1, then only.
Vishal, can you send us your email IDs, Vishal, so we can contact you?
Yeah, I've sent in the chat box.
It is there in the chat. Is it there in the chat?
So if there will be some complicated, I'll send you some Google link and we can discuss there. And if that is a bit easier, I'll just try to solve and send you back you the screenshot of that.
But where do you share the Google link normally? Because I don't.
I'll send it in the Gmail, like from wherever I'm getting the mail, I'll send. Try to discuss.
Personally, you are.
Yeah.
Oh, great.
Why are we not handling it in the forum?
Yeah, you can set it on the forum also. I'll try to explain it there also.
I think
if somebody is
asking question should ask in the forum, that will be more helpful for everybody. No?
Yeah, so if somebody is having issue, you can directly post on the discourse. Okay, so there 4 or 5 people are there. So if somebody is free, he'll try to sort out there. And if you want me to, you can just tag anyone. Like you can just click on @ and Vishal, you can tag me, and maybe I can get directly the notification on the discourse also, and I can write it. Okay.
Okay.
So whatever is suitable for you can just type, because sometimes there is a bit little basic problem. Somebody generally doesn't post it on the Discord, so you can just mail me. That is also fine. I'll just reply to the mail. Okay. The Discord
Sir,
is
we
also
have to use our student mail ID to contact.
Only student mail ID. I'm not replying.
Yes, sir.
Okay.
Yeah. So okay, it was great. Yeah, it was great.
Try to accommodate that change, sir. That first session should be on open session and then activity and then graded.
Okay, that I'll convey to the team.
Vishal, I just sent you the question. If you can check your mail and see if it is you received it, it'll be really closing the loop.
I didn't receive them.
Uh-oh.
Maybe you'd have sent someone. Vishal @ I'll send it again.
Vishal @ onlinedegree.iitm.ac.in, right?
Yeah, I got
it. There you have it. Just came.
Okay, I'll try to solve it and send it to you. Okay.
Thank you, Vishal.
Okay, thank you, everyone.
Thank you so much, sir. It was really helpful.
Thank you, Vishal.
Thank you. Have a nice evening.
Thank you.
Thank you, sir.
Yeah, thank you, everyone. Good night. Bye.
Bye.